Okay, so let's look at your work solution, your solution. So for the first question for integration techniques, right, it will be focusing on what I call the inverse chain rule or reverse chain rule. Over here, reverse also okay. So what's going on? Because what's going on here is that when you differentiate a composite function, like for example, you're differentiating sine of tangent of 2x, what happens? You will get cosine, then everything else inside you copy paste. Differentiate tangent, you get secant square, so you multiply. Then everything else that's inside you copy paste. And then there's still a 2x, so you have to differentiate again, so multiply by a 2. Is this part clear to you?
Yeah.
So if you want to integrate, you just need to integrate both sides. The integral and derivative will cancel off. I know it's not very accurate to write that. I should put on extra dx. So and dx. The proper way to write it would be integral of the right hand side cosine of tangent 2x times secant square of 2x times 2 dx. This will be equal to the sine of tangent 2x. Right? This is called the reverse chain rule. Oh, don't forget a plus c. All right, and I wrote down in detail for you how exactly you work it out. In general, it will be a g of a f of x, and then you have the derivative of the inside multiplied to it. Oh, similarly over here, okay, wait, actually, yeah, I'll just work with this. So then after that, when you integrate the g, little g, it becomes a big G. Oh, I realized I made a mistake here. It should be a f of x inside this expression. Sorry, should be f of x. Okay, so in this case, if the little g happens to be x power n plus 1, or actually no, another mistake. It shouldn't be n plus 1. It should be just power n. Then it means that I'll have a f of x to the power of n. Then if I want to integrate this, it will just become f of x to the power of n plus 1, but divide by n plus 1. Add 1, get the new power, divide by the new power. But make sure you have a multiplication by the derivative of the insides. Right? Similarly, now if this g of x is now 1 over x, it means I'll have 1 over f of x. Right? G of f of x will become 1 over f of x. Then also, there's the inside being f of x, you need the derivative at the left side, multiplied. Then when you try to integrate this, if you rewrite this format, it's really just f prime on top and f below. You try to integrate this, you'll just get ln of the modulus of f of x plus c. Can?
Okay.
Yeah. Okay, good. So most of the questions you got it right. Let me just oh, what's going on? Okay, my app just crashed on me. Okay, anyways, yeah, so coming back, yeah, so most of them are correct except for a few. You forgot to use chain rule. I wrote down chain here to indicate that. Like for example, over here, you're supposed to introduce the 3 then 1 over 3 here. Or if you're faster, you can do it straight away. And yeah, you can do it straight away, which is good. You did it over here. Oh. Then you got this. So over here, when you pick your f of x to be sine 3x, something went wrong with our derivative. You see, differentiate sine, you get cosine, but inside still have 3x. So in front, you still need 3 times. But it's so that's why you need a 3 times cos 3x, right? The f prime x in front on the left.
Oh.
Yeah, but you didn't write that down. But never mind. I think you're already very used to using the chain rule, reverse chain rule. So you just remember divide by 3, divide by 3. So your integral is still correct. Even though your derivative is wrong. Yeah, okay, that's good. Do that during exam and it's fine. Nobody will look at this. I think so. Okay, this one good. You use modulus. Next one, modulus notation. You forgot to end with a modulus. You put a curve here. Right, must be consistent. Modulus.
Okay.
Yeah. Okay, next one. That was question 2C. Then question 3A, chain rule again. here, if you integrate 1, you get an x, that's good. You integrate cosine, you get a sine. Yes, but then there's a 6x here. What do you have to do? Divide by 6. Can you remember this?
Yeah.
The reason is, let's check. If I differentiate sine of x, sine of 6x, I will get cosine. But chain rule tells me I have to multiply by derivative of the inside, which is 6. So if I now try to, integration and differentiation are reverse function, are sort of reverse of each other. So that means that sine of 6x equals to the integral of cosine 6x times 6. Is that clear?
Yeah.
Right. Differentiation and integration, they cancel each other off, sort of reverse functions. Okay. Then so now if I want to find integral of cosine 6x, dx. This guy, and this guy. Who do I need to get rid of? Times 6. Bring over becomes a. Okay, maybe I should do step by step. Bring out becomes 6 times. Then after that, you bring over become 1 over. Exactly. So sine 6x over 6. Divide by 6. Proceed. That's why you have a divide by 6 here. Can understand?
Can.
So in general, please remember this. Maybe I should go back to that specifically the first time, specifically the second time, specifically the third time. You need to remember this is if the g of x is equals to some linear function ax plus b. So it will be integral of f prime of x times, what would it be? Okay, I'll put an extra square bracket here. A times f of x plus b dx. It will just be equal to capital A. In this case, what would it be? It will just be f of x, then you divide by a. I'm getting a bit confused right now. Yeah, I think it will just be the integral. Hold on a second. No. I think I this is a lot simpler if I write it specifically. What I mean is if you try to integrate, for example, let's say f of ax plus b. Okay, you need an extra a in front. Then you can integrate it to get your capital F of ax plus b. Or more simply, you can divide the a over, which means integral of f of ax plus b equals to 1 over a times f of ax plus b, where capital A is the integral of f. Okay. Differentiate the big F of x will give you the little f of x. So an example to this would be what we showed just now. Integral of cosine, let's say 6 theta, d theta. I change the x to theta. Here my a will be 6, my b will be a 0. Then it will just be the integrate cosine, you get sine, right? So just copy down sine. What's inside? 6 theta, copy down. But you have to divide by 6, right? Over a here means divide by 6. All right, yeah, that's all. Plus C. Don't forget the plus C. Okay, moving on. Yeah, must remember to divide by 6. And here, there was a mistake. You are doing it a bit too fast. Over here, 1 over 1 minus cos 2x. Simplify cos 2x to 2 cos square minus 1 is correct. But remember your bracket, your minus sign you bring in, what do you actually get? You get 1 minus 2 cos square x plus 1. 1 plus 1 gives you 2, so it's 2 minus 2 cos square x. So far, okay?
Yeah.
Then if I factor out a 2, what do I get from my 2 minus 2 cos square x? 2 bracket 1 minus cos square, which is if I then you have a 2 at the denominator, so I can take out a half. So it becomes half times the integral of 1 over 1 minus cos square. Is this part okay?
Yeah.
Then 1 minus cos square is actually sine square, so we get sine square here. Then what's 1 over sine square? It's actually cosecant square. Is this part okay?
Yeah, can.
Can then integral cosecant square, technically it is not in the MF26. It is not in the MF26. So you just gotta somehow know it. Integrating cosecant square.
Memorize.
I typically don't memorize it. I try to derive it. But in this case, okay, there's sine square plus cosine square equals to 1, right? How do you get cosecant square? It's 1 over sine. So I divide throughout by sine square, I'll get 1 plus cotangent square equals to cosecant square. Now, this is the lazy way of writing out the Pythagorean identities. S square plus c square equal to 1, sine square plus cos square equal to 1. Then if I replace this with 1 plus cotangent square, does it help me? To be honest, also not really. I never memorized those formulas that are not in the formula list because I know that A levels will provide the information. They will probably give you the hints in a multi-part question. So like part 1, they'll ask you differentiate this to get that. Maybe in part 1, they'll tell you differentiate negative cotangent x and show that it's cosecant square. Right? Then later on, they give you this question. This is your part 2. Part 1, or maybe they won't give it so directly. They'll tell you differentiate cotangent x and give and you show that it's negative cosecant square. But over here, it's positive cosecant square. So you just have to automatically fill in the extra negative 1 there. Right? Maybe I should so like part 1, they'll say show that the derivative of cotangent of x is equals to negative cosecant square x. Then part 2, it will say hence find integral of 1 over 1 minus cos x dx. Something like that, huh? Okay, then from there, you need to know that derivative of something equals negative cosecant square. You can work backwards. Integral cancel off, means integrate negative cosecant square dx equals to cotangent x. Yeah, maybe I just write down in blue. This implies that integral of negative cosecant square of x dx equals to cotangent of x plus c. This is the thing you should remember. Differentiation and integration are reverse of each other. And there is always this trick. If you know the derivative equals to some answer, you can work backwards. Integral of the answer will give you back the original thing you are trying to differentiate. Integral negative cosecant square x dx will give you a cotangent x. Can?
Can.
And then of course you can just change the sign. So positive here, negative there. Then you can get integral of cosecant square is negative cotangent, which is what we have over here, negative cotangent. Oh, do you need me to show you? Differentiate cotangent is negative cosecant.
Can.
Okay, let's change rule. Let's do it at the top, or maybe. Actually, I already wrote it here, huh? So let's just go through it. So cotangent x here is actually cosine over sine, right? Remember, tangent is sine over cosine. So cotangent is the reciprocal. So you flip the fraction around, cosine over sine. So now you have a function on the top and the bottom with a negative out front. I'll just leave the negative alone first with a square bracket. Then I deal with the derivative of this quotient, right? Quotient fraction. So you have to use quotient rule. So remember the rule is low d high, less high d low, draw the line and square below. You know this, huh?
Yeah.
D high, less high d low. Did I go through with you? I can't remember.
No, but then this one for email.
Yeah, exactly. Okay, good. So that means you just get the bottom guy multiplied by derivative of the top guy, cosine differentiate, get negative sign, minus the top guy, cosine, differentiate the bottom guy, which is cosine. Multiply together. Okay, so we can just use some trivial identities. Sine times sine gives you sine square with an extra minus sign. Cosine times cosine gives you a cosine square with an extra minus sign. But there's a minus out front, so you can distribute, you'll end up with sine square, positive sine square x plus positive cosine square x divide by sine square. This part okay?
Can.
Then what sine square over plus cosine square? It's just 1. So replace the numerator with a 1 over sine square, which is cosecant square. 1 over sine is cosecant.
Okay.
Right. Just remember no co. Cosecant x means 1 over sine. There is no co here, there is a co here. Secant x means it's 1 over cosine. There's a co here, there is no co here. Co, no co, co, no co. Maybe I should be consistent, underline. Then the last one will be cotangent of x. Or just cut COT. This one is just COS. It will be 1 over tangent x. No co. And of course, if you square it, you also have to square. Okay, can. Yeah, that's this question. Negative half cotangent x. Part D is fine. Your solution is very interesting. This is correct. It's correct. But the answer key provided a different solution, which is identical. Okay, your working is very good. But let me show you a different way that they did it. So we start off with 1 plus cos x, right? It looks very similar. Just now was minus, now it's plus. Now how do we deal with this? We start off with finding out the double angle identity. Recall the double angle identity. Cosine 2x is 2 cos square x minus 1. So if I now replace the 2x down by half its angle, that means that everywhere else I also half the angle. So I end up with cosine x equals 2 cos square half x minus 1. Is this part okay?
Yeah.
Half the angle, half the angle. Okay. So now I can replace my cosine x with this formula here, 2 cos square half x minus 1. What happens to your 1 and minus 1? They cancel off. So I'm left with 1 over 2 cos square half x. Is this part okay with you?
Yeah.
But half is 1 over 2 cos square is really just 1 over 2 cos square of dot 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 is really just 1/2 times 1 over cosine square of dot dot dot. Dot 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 being the x over 2. So what is dot 1/2? You just leave it alone. What is this 1 over cos square? It's just secant square. Is that okay?
Yeah.
Good. Then what's the integral of secant square? Tangent. No? This one you learn from A max before already. Differentiate tangent, you get secant square. And chain rule, there's a half x here, so in front you also have a half. So you can use inverse chain rule, get tangent x over 2 plus c. Okay. you can check with your calculator. This one quickly, you just type in like maybe the angle as 10 degrees or something. Then you try tangent of 10 over 2, you get some number. Then after that, you try your answer, negative cotangent, which is really just negative 1 over tangent. Let's say 10 degrees. Plus cosecant is 1 over sine of 10 degrees. Then this one will be tangent of 10 degrees divided by 2. You realize that the values will be exactly the same. Oh, with 10 degrees. Then you can try for a few other examples if you're not convinced. Okay, yeah, your answer is perfect. Very good. Very interesting. Who taught you to do this? Oh, you do too much complex numbers already.
I think so.
Yeah, then rationalize everything. Okay, that works. I didn't think of doing this. Very smart. Okay, moving on. Yeah, this one you're just using the product to sum formula in the formula list. The key thing that you need to take note of here is that we want to avoid negative numbers as much as possible, just to prevent careless mistake, right? So we would want our angle P and our angle Q. You know which part of the formula list I'm looking at, right?
Yeah.
The sine P plus Q equals 2 sine half P plus Q cosine half P minus Q. Directly below tangent 2A and the others. Yeah, so the goal here is we want to avoid negative as much as we can. So specifically, your P and Q, we try to make sure there's no negative. P, Q, and ensure it is positive. How can we do that? It means that we need to start from our product and we work backwards into our sum, right? We need to make sure that this P and this Q are positive, and you manage to do that. That's good. The trick here is you need to identify who is your half P plus Q, who is your half P minus Q. In this case, do you notice 5x over 2 and 3x over 2? This guy is the big angle, that guy is a small angle. 5 is bigger than 3.
Yep.
So we try to make sure that look at the formula, you got half P plus Q, half P minus Q. you try to always make sure that your plus Q, the plus version is bigger, right? So you use the big angle. Then your P, half P minus Q, the minus one, you use the small angle. Guaranteed, if you do that, you will recover a P and a Q that will be positive values. Usually lah. Okay, so how do we, what's a faster way instead of doing simultaneous equations all over? Don't need. You just need to remember this trick. Maybe I write down the formula for you. We are using sine cos, so it's the first formula. Let me copy down the formula. In the 000 syllables, this was not provided in the formula list. Have to memorize one. Don't need. Now it's modern times. You just use MF26 can already. Okay, don't need to worry. So what is the trick over here? You need to remember. Don't go and do simultaneous equation, please. Memorize this instead. P, remember I told you, wait, I didn't tell you, sorry. This one, no choice, have to memorize. P, just remember that it's the big angle, so you want to plus. You take the big plus the small. In this case, P plus Q over 2 is 5x over 2, good. P minus Q over 2 is 3x over 2, that's also good. So here and there, you just add them together. What do you notice when you add the P plus Q over 2 plus P minus Q over 2? Do a bit of algebra. Combine, single fraction.
The A cancel out.
The what cancel out?
The Q.
The Q cancel out, yes. Sorry, it's my handwriting very bad.
It's okay.
Yeah, it's a Q. So combine to a single fraction already, you get P plus Q plus P minus Q. Yes, exactly. The Q cancel off. You're left with 2P. P plus P is 2P. Divide by 2, and you end back up with P. Correct or not? So it's very simple. To recover P, please don't go and do simultaneous equations. Just remember, add the two angles. Big plus small gives you P straight away. Then how about Q? This one have to be careful. This one have to be careful. It has to be a minus over here. Let me ask you a question. 2 minus 5 versus 5 minus 2. Are they the same?
No.
No, off by a negative sign. One is -3, one is +3. So over here, similarly, when you have a minus in this magic formula I'm giving you, you need to make sure that you get the order right. It will always be big on the left, small on the right, then big minus small. Likewise for the plus one, big on the left, small on the right, plus in between. But for plus, you can swap around, so it's fine. For minus, I have to be more strict with you. Big must be on the left, small must be on the right. Are we clear on this?
Yeah.
So what happens when you do big minus small? What I mean is P plus Q minus P minus Q over 2. Let's do a bit of algebra. We get P plus Q over 2. Subtract away, there's an invisible pair of brackets every time I put a minus fraction. So minus away, if I distribute the minus, I will get minus P plus Q. Then divide by 2. Combine into a single fraction. Agree?
Yes.
What happens to your P? Cancel off.
Oh.
I use a highlighter. Then I get Q plus Q is?
2Q.
Divide by 2 is?
Q.
So you get back your Q. So easy. Big minus away small. 5x over 2 minus 3x over 2. Remember? Here and there. Then you get back your x. Very fast one. You see, all you need to do is this line. You can even do it in your head. This line, do it in your head. You can recover P and Q. Don't need to do simultaneous equations. Can?
Can.
Okay. So another way that you could have interpreted this formula is to remember it like this. This is equal to, I'm going to use a new notation, 2 sine of A cosine of B. So we let A represent P plus Q over 2 and P minus Q over 2 represent B. Then this sine P is really just plus sine Q. What would this P now be? What's the formula?
A plus B, then A minus B.
Exactly. So this is a more useful formula, actually, for you to use. Can?
Can.
Yeah, just remember, P is big plus small. Q is small, big minus small. Can you remember this? P is big plus small, Q is big minus small. Very important. So then you get back your 4x and x. Here you never exactly use the This is your sign P and that's your sign Q. But you swap them around because you know that addition allows you to swap them around, right? This is your P. That's your Q. Oh, I hope you understand that. You don't anyhow swap the order. If you use the formula, I think it's safer if you just use it exactly. Sign P on the left, sign Q on the right, and plus in between. But I'm sure you understand that addition, you can swap the terms around. Like 2 plus 3 and 3 plus 2 is the same thing. So that's why you swap them around. So it's still equal. Good. Can then now how to integrate? Yeah, just take note that after you integrate, sine you get negative cosine. You should not put the integral sign anymore. Integral dx should drop. Understand? Once integrate, yeah, you already did something similar, like I mean, sorry, no, you managed to do that safely previously. You see, integral of something dx. Once you integrate the 1, you get an x. Once you integrate this guy, you get 3 ln. Do you still need to put the integral in dx?
No.
Don't need, or you should not, you should not. Okay. Okay, moving on. This is correct. Which is the next one that I got wrong? This is good. Okay. Chain rule again. Can I have a request for a short 5-minute break here?
Yeah, sure.
Yeah, we come back and we talk about part G. So you can go and read again. Here the main problem is chain rule. You see there's an extra 2a here, a here. You're missing a division. And also you go and check this part. Something went wrong with your substitution. Okay?
Okay.
Something went wrong over here. There's a 1, not a 0. Okay, I'll come back in 5 minutes.
Okay.
Mic test, mic test.
Can hear.
Okay. Ken. Okay, let's go through this. Have you figured out your mistake?
I never divide.
Yes, never divide. So over here, the one that I put across there and I say chain rule, it's basically telling you that you forgot to reverse chain rule. You forgot to use that rule over here. You basically after you integrate cosine, you get the sine, but you still need to divide by 2a, the coefficient of the theta. Can you understand that 2a is the coefficient of theta?
Can.
So likewise over here for cosine a theta, you integrate, you get sine a theta, then you need to divide by a. All right. Then after that, you need to sub in the upper and lower limits. Over here, you sub in correctly. You also cancel off correctly. But over here, can you tell me what is this angle here? Can you see? You start with, you want to minus away this guy, but you sub in with the lower limit, pi over 4a. So it's 2a times pi over 4a, right? A and a cancel off. 4 and 2 cancel, becomes a 2. So what is this angle here? Oh, I can't hear you. Sorry, mic test.
Oh, sorry. Hello?
Hello.
Yes.
Yes, what is this angle here?
Pi over 2.
Yes, pi over 2. So you know it's pi over 2. Then what's the sine of pi over 2?
0.
No. What's pi over 2 in degrees if you do?
45.
Huh? Your Emax teacher is crying.
90.
90 degrees. So what is sine of 90 degrees?
1.
Yes, draw the sine curve like this. 90, you get to 1. Another 90, you get to 0. Another 90, you get to -1. Another 90, you get to 0. Okay?
Can.
Okay, so this is 1 out of the, I mean the y coordinate at least. Okay, so this is 1, not 0. Okay, please be careful. Also, by the way, error carried forward, divide by 2a, divide by a. So you need to have the divide by 2a and divide by a over each of the fractions. So anyways, these values are 2a multiplied by a pi over 2a upper limit. Let's just sub in the upper limit first. Let's see what it is. 2a multiplied by pi over 2a is just a pi. So sine of pi over here, sine of pi 180 degrees, we will give you a 0. Then over here, a times theta. If you replace theta with pi over 2a, the a cancel off, you're left with pi over 2. So same thing, sine of pi over 2 is a 1. Okay, so here is a 1. Likewise, over here, we already clarified that it's a 1, but over here, you got it right. It's square root 2 over 2. Yes, sine 45 degrees, pi over 4. Then simplifying. So we get, also you forgot a pair of square brackets, half times. Okay. Then you need half times again with square brackets, but this time, okay, I wrote it the correct way. Half times square bracket, then you replace it with the actual values. 0 divided by 2a, 1 divided by a here, 1 divided by 2a here, square root 2 over 2 divided by a here, then with a minus in between. Here I put bracket for aesthetics reason to make it look nice and symmetrical. You don't need to put these pair of brackets at the left. But the right one, after the minus sign, you have to put in the bracket. Okay, then now you just simplify. 0 over 2a becomes a 0. So 0 plus 1 over a is just 1 over a. Again, I put the brackets here. It's a bit extra. I just want to make it look nice. Then minus 1 over 2a plus square root 2 over 2 divided by a. You can bring the a on top, so you get square root over 2 times a. Is this part okay?
Can.
Okay, good. Then since now you got both denominators 2a, you can add them together, the numerators. You get 1 plus square root 2. And then after that, I deal with the minus sign. Minus, remember, after you minus a fraction, there will always be this invisible pair of brackets that's introduced. Invisible pair of brackets introduced at the numerator of the second fraction. Like for example, if I give you a quick example, 2/3 minus away 5 plus 7 over 3. Of course, 5 plus 7 is 12, but if I leave it as 5 plus 7, this will be equal to 2/3 minus 5 minus 7. Is this part okay? The second minus.
Yeah.
Must be a minus because there's an invisible pair of brackets, the minus bring into each of them. So positive 5 become negative 5, positive 7 become minus 7. Okay, can. So yeah, same thing over here. You bring it in, then you'll end up with a -1 and a minus square root 2. So -1 minus square root 2. Then over here, there's a 1/a. Cannot just combine straight away because the denominator is different. When you subtract fraction, you need to make sure the denominator is the same. So you multiply top and bottom by 2. So now we got 2a and 2a and a 2 on top. So you can just add the fractions together. 2 minus 1 minus square root 2. Okay. Then what's 2 minus 1? It's just 1. So you get 1 minus square root 2 on the numerator over here. Is that okay?
Yeah.
Don't forget divide by 2a. Don't forget the half. Multiply the 2 into the 2a. You get a 4a. Then that's your answer. 1 minus square root 2 divided by 4a. Can?
Can.
Okay, good. That's your answer. Moving on. Part H, again, chain rule. Okay, let's take a look at the mistake. Over here, very fast, you can straight away get the angle. Basically, you need to realize that you're using, if I just, let me take a look at the formula list. You got sine multiplied by sine. So in that case, you would use the fourth formula, the one involving cosine P minus cosine Q. Then how do you recover P? You just need to add the angles together. How do you recover Q? You just have to subtract the angles. Maybe I'll write it down for you. Over here, if I call this angle here P plus Q over 2, which is the A lah. But I'll just write it down as P plus Q over 2. And this other guy will be a P minus Q over 2. The reason I chose them as the plus and the minus is because I see here there's a plus and there's a minus. This is the big angle. This is the small angle. Okay. This will help, once you identify the big and the small, it will help you to prevent negative angles being formed in your angle P and the angle Q. If you swap them around, what will happen? What if you swap them around? Because sine multiplied by sine is the same thing. You can swap them around. So if you treat P minus 1 theta as P plus Q over 2, and P plus 1 theta you treat as P minus Q over 2, what will happen?
It become negative.
Become negative, which one? Angle P or angle Q?
The Q.
Q, correct, because you need to subtract this one minus that one. It means you get a small minus away a big, which will give you a negative angle. Okay, or at least not negative, it will give you a negative sign in your angle, which is quite confusing. I want to avoid that as much as we can. Additional confusion is not very confusing, but you need to remember sine negative theta equals negative sine theta. You can take out the minus, or cosine negative theta is cosine theta. That one you cannot take out the minus because of the even function, because cosine is an even function, symmetrical about the y-axis. Yeah, I explained before that identity already. Also, yeah, then that's this 2 pi theta is just P plus Q over 2, add on P minus Q over 2. And this second angle 2 theta is just P plus Q over 2, subtract away P minus Q over 2. I swap back already. The plus is on the left and the minus is on the right. Okay. Yeah, good, you got the angle. But then there was a mistake over here. Again, it's because of chain rule. Integrate cosine, you get a sine, but you have to divide by 2 pi. Likewise, for the other guy, integrate cosine 2 theta, you should get sine of 2 theta, but you divide by 2. Here, I'm not sure why you suddenly got extra pi introduced. What's going on?
I think I just copy the front part. I thought it's the same. Yeah.
Oh, you copy it from here. Wrong. No, cannot. Must follow consistently. This term is cosine of 2 theta, so the angle is 2 theta. It's not 2 pi theta. Can?
Can.
Can. Yeah, so error carry forward all the way. Then in that case, yeah, you have divide by 2 pi, divide by 2, divide by 2 pi, divide by 2, sub in the 1, then sub in the 0. Okay, so let's see. Do you understand this working?
Yeah, I'm just using the divide.
Yeah, I haven't simplified it for you. So let's just simplify it now. So sine 2 pi in this case is just is what?
Divide by 2 pi.
No, sine of 2 pi. Don't need to divide by 2 pi. Just tell me sine of 2 pi is, the numerator is
0.
0. Then do you even need to use a calculator for this? 0 divided by anything. It's just 0. Don't need.
Oh.
This will be negative half square bracket 0 minus here. Be careful, no more pi. So we are replacing the theta with 1. So it becomes 2 times theta, 2 times 1. So the angle is actually 2. Sine of 2. 2 what? 2 radians. If you want to convert it into degrees, you can just multiply by 180 over pi. Let me see. So over here, this 2 here is actually representing radians. Oh, by the way, do you know that for differentiation and integration, you must always work with radians when dealing with trigonometric expression? Must be radians.
Oh,
Okay. If it's degrees, right? Let's say, for example, oh, you didn't know. Okay. Let's say you do a quick one. Let's differentiate sine of I don't know. Let's say x, and they say x is in degrees. This is very, very weird. Very, very rare. Nobody will do this. If they tell you it's in degrees, what you need to do is to convert it into radians first. How do you convert degrees to radians? You have to multiply by what over what?
Pi times pi over 180.
Okay, yes, correct. Convert into radians. Yes. So pi over 180 degrees. I'll leave it as 180. Then because there's an extra coefficient, when you try to differentiate, you actually end up with pi over 180 times the sine, sorry, not sine, times the cosine of this guy. Okay? That's your final answer. If you were working with degrees. So nobody works with degrees when we're in calculus, doing differentiation, integration. The x, the argument of a sine, cosine, or tangent, a trigonometrical function, will always be in radians. Okay? By default. So over here, 2 radians, if you really want degrees, multiply by 180 over pi, it's 114.591559 degrees, according to my calculator. Or 114 degrees. So not important, just leave it as sine 2. Then don't forget, you have to divide by 2 pi. Remember the 2 pi there? Oh, sorry, 2. It's not a 2 pi. It's a 2 here. Sorry. We're looking at the second term. First term is 0. Second term is this guy. Close the bracket. Minus away, next one. Sine of 0 again is 0. Divide by 2 pi is still 0. Then sine of 0 again is 0. Divide by 2 still 0. Close the bracket, close the bracket. Good? Okay, good. Then now you simplify, you just end up with a positive sine 2 over 4. Is that okay?
Yeah.
Okay, good. So let's carry on. Question 4 is fine. Question part B also fine. 4C, there's a misconception. What you did is okay. What do you do? You split it out as you do long division here, and then you got an x, you integrate the x, get x squared. That is actually slightly inaccurate. Should be x squared over 2. Sorry, I take back my correct. Oop, have to divide by 2. Remember? Add 1, get a new power, divide by new power.
Yeah.
Should be x power n plus 1, then divide by n plus 1. Okay, Ken, so this part is wrong. Then what you did next is the 2 plus x numerator, you split it out as 2 and then plus x. Okay, that's fine. Then after that, you multiply by 2 and multiply by half so that you can get the f prime x on top and the fx below. So that you can integrate this to get your ln of modulus x squared minus 1 with an extra half in front. This is okay. But the middle term is wrong. Do you know why?
No.
How do you check that you integrate correctly? You differentiate and you work backwards. When you differentiate ln, what do you get? Let's do it together.
Over.
Let's just ignore the modulus. Assume it's positive. 1 over, okay? 1 over, what else? The mistake you've been making all the way.
2x times 2x.
Yes, times 2x. So you actually need a 2x on the numerator. You actually need a 2x on the numerator before you can start to integrate. Integrate 2x over x squared minus 1 will give you back your ln. But over here, it's only 2. It's not 2x. And what you did is you factor out the 2, I think. So you factor out the 2, then you're left with 1 over x squared minus 1. How do you integrate 1 over x squared minus 1? It is not the same as this guy. Not the same as integrating 2x over 2x squared. It is not the same as integrating 2x over x squared minus 1 to give you ln of x squared minus 1. Not the same. Because there's an extra function on the top. A function which is just x. That makes a huge difference. Because now we are actually dealing with integral of 1 over x squared minus 1. You have no choice. You should use partial fractions. Now, there is a formula in the formula list that allows you to integrate functions of this format. X squared minus 1. The 1 over x squared minus a squared. You get 1 over 2a ln of x minus a over x plus a. But I don't recommend using that formula. I recommend you to do partial fractions, then integrate them term by term. What do I mean? I'll show you over here. So, okay, I look at the question again. So this is the problem integral of 2 over x squared minus 1 dx. It is not the same as this answer. Now I'm going to demonstrate to you how to get the correct answer to integral of this guy. So first step would be to do partial fractions on 2 over x squared minus 1. I could also leave the 2 alone, the factor of 2, and just integrate 1 over x squared minus 1. But it's the same thing. So I'll just bring along the 2. So x squared minus 1 is actually just x squared minus 1 square, which is x plus 1 times x minus 1. Then you can split out as partial fraction a over x plus 1 plus b over x minus 1. So now you can just multiply throughout by this common denominator. You'll end up with this expression. 2 equals to a times x minus 1 plus b times x plus 1. So far, okay? Can this one? Then now I sub in x equal to 1. What do I get? 2 equals to 2b. X minus 1 becomes 0. 1 minus 1 is 0. So I can ignore the a term. Then here 1 plus 1 is a 2, so 2b. That's how I get 2 equals to 2b. Solving, I will get b equals to 1. Okay?
Okay.
Then now I sub in x equals to negative 1. What happens? X here becomes negative 1 plus 1, which is 0. 0 times b is 0. So that means I'll be left with 2 equals to a times negative 1 minus 1, which is negative 2a. Solving, I get a equals to 2 over negative 2, which is negative 1. So now I just sub back in. Wrong order. This one and that one. Negative 1 here and 1 there. Okay?
How I know when to use the partial fraction?
Okay, later I give you a formula list of dealing with all the different formats. I'll give you a mind map on what to do when you look at our integral. Okay? This one, the reason is because I see that there is a quadratic denominator. When it's a quadratic denominator, you either complete the square, you use a standard formula, or in this case, it is a standard formula, but I would prefer using partial fractions. Okay, so 3 tricks. It's just complete the square, partial fractions, or use a standard formula from the MF26. Yeah, later then I talk more about it. So here we just go on with the partial fractions, split it up into this, integrate term by term. So you get, now can we integrate to get a ln? Yes, we can because derivative of x is just a 1. right? So we are allowed to use the ln formula now. Integrating, then we'll get ln of x plus 1, but don't forget the negative 1. I factor it out first, so I get a negative 1 outside. Then integrate 1 over x minus 1, I get ln of x minus 1. And don't forget the modulus. So now there's a minus here, there's a plus there. It means that this guy will go to the numerator, that guy goes to the denominator. Because we are doing okay, essentially this guy, if I just change it to blue color, will just be the same as swapping it around. So it means I'll get ln of x minus 1 modulus minus away ln of modulus x plus 1. There's a difference of ln. What happens when you have a minus? It becomes a quotient, right?
Divide.
Difference to quotient, divide. Yes, because of the logarithm rule. So, oh, I forgot to draw an extra line here. Sorry. Then modulus on top, divide by modulus below, you can actually combine them to get modulus of the entire thing. Okay? It's like modulus of -2 divided by modulus of -5. It is exactly equal to modulus of -2 over -5. Right? It's the same thing. Yeah, so that's your final answer. And you can also verify using the, what do you call that? The MF26 formula. The one, do you have the MF26 open with you?
Yeah, I have.
Go scroll down to the bottom, page 4. If I can show it over here, let me. Got it, page 4. Then in page 4, I think there is the. Oh, where is my? Yeah, there's the 1 over x squared minus a squared. That is f of x, and the integral is 1 over 2a ln of x minus a over x plus a. You could also use that formula.
Oh.
But I don't like to use that formula because you need the extra condition that x is more than a, and I don't know for sure. Okay, I don't know for sure, and I find it quite annoying to have to deal with it. I finally found my version. Okay, so over here, this formula, we could have used this formula, but I don't really like it because you need to satisfy this condition x more than a. How do I know that? I don't know. That's the problem. So I don't like to deal with this. I will just do partial fractions, and then I'll just integrate them piece by piece, term by term. Okay? Like this, term by term. I get ln, then later I combine. Okay, okay. Can, yeah, so this should be the correct answer to the middle term. And x squared over 2 should be the correct integral of x. Yeah. And then over here, there's a plus c, that's good. So yeah, just make your own corrections later. Write it out neatly. Okay, part D is fine. You forgot a modulus sign here. After a plus 1 must end with a modulus. You see? You never put modulus.
Okay.
So please put modulus. Okay, moving on. I mean, you did put a modulus, but you forgot to close it. Okay, what went wrong here? Part B. Transfer error. You see minus on top should stay as a minus. How come suddenly become plus?
Oh. Yeah, I think
Yeah, careless, but otherwise it's correct. Otherwise it's correct. Okay. Part C. Wow, what? Totally wrong. Not sure what's going on. Let me go through this entire question. Is that okay? Can I? Okay, let's go. So this is part C. Let's take a look at this question. This is question 6C. Okay, this is the integral of 3x plus 4 divided by the square root of 8 minus 6x minus 9x squared. This is another case of the integral. Later I talk about I give you a mind map. This is the integral where you have a quadratic, but it's trapped underneath a square root. This one, usually if there are 3 terms, right? The constant, the linear, and then the quadratic, you will need to use the, what do you call it? The completing the square. Okay?
complete the square.
Usually. But before you carry on with that, what you realize is that the numerator here, there's a 3x plus 4, which is power 1. The denominator here, power 2, right? So that means that we can actually use reverse chain rule. Do you see that? Do you see that?
How?
You can interpret this as remember the rule was what? Integral of f prime of x multiplied by g of f of x dx. So what is our function g? What is our, wait, let's identify what's our f of x first.
The 8 minus 6x minus 9x squared.
Yes, correct. So that means that f of x, if we let that be the thing underneath the square root, then we need to now identify what's our g. Notice that it's multiplication over here. And we need a f prime x. Okay, maybe we find f prime x first, then it will become more obvious. So this will be -6 minus away 18x. -6 minus 18, 3x plus 4. Can we make them the same? Are they the same first? Definitely not, but can we make them the same? Can. By rewriting it as some a multiplied by 3x plus 4 plus b. This is a trick you should know. You can always rewrite it in this format. You just need to figure out what's a, figure out what is b. Okay, how can we do that? Let's see. We want the, oh, sorry. No. Should be the other way around. The numerator, we start with 3x plus 4. I want to rewrite it as a times of -6 minus 18x plus b. How can we do that? You start with a 3x, you end up with a times -18. So you can form an equation already by comparing coefficient. Compare coefficient of x. We'll get 3 equals to -18a. This implies that a equals to -1/6. Yes?
Yeah.
Then you can compare the constants. You get 4 equals to -6a plus 6. Of course, we'll still get a equals to -1/6. Oh, sorry, no, that's not a 6, that's a b. Oh my goodness, I got confused. Sorry. So it will become 4 equals to -6 times -1/6 plus b, which simplifies into 1 plus b, which means that b equals to 3. Yes? Clear?
Yeah.
Okay, good. So you got b equals to 3. Then what do we do next? It means that now this 3x plus 4 over square root whatever, we can actually rewrite it. Do you see that? We can actually rewrite it like this? 3x plus 4 multiplied by 1 over square root. Do you agree that 1 over the square root of x is actually just x to the power of -12?
Yeah.
So that means that this 8 minus 6x minus 9x squared is like your x over here. But you replace the x with a quadratic. 1 over a square root gives you x, the whatever. Okay, 1 over the square root of whatever will give you whatever raised to the power of -12. So it means the whatever in this case is the quadratic raised to the power of -12 dx. Does it look more familiar now? Prime x.
Yeah.
And then you got fx. And then in this case, it's to the power of n. Looks almost like that format, right? You can use the reverse chain rule.
But it's not the derivative yet.
It's not the derivative yet, but it's close, right? That's the intuition you must first have, right? Oh, the g of x is x power n. Almost. So we need to force this 3x plus 4 to look like our derivative. How can we do that? Use the trick over here. We figure out what's a and b, right? So I'm just going to replace my a here with a -1/6 and the b here with a 3. So that means that my 3x plus 4 here can be replaced with -1/6 times of -6 minus 18x plus 3 bracket bracket, then I multiply by everything else. Sorry, let me bring my working to the right side so I have more space. Integral. Can you see? I replaced this 3x plus 4 by this expression.
Yeah, I think I tried to.
Yeah, you did something similar, but you forgot to add on a constant. I think 2. It should be a 3 there. I think you got the constant wrong.
Yeah,
Should be a 3. Okay, let's just continue doing finishing up the solution. Okay, so over here, what we can do now is you see that there are 2 terms, right? First term here, second term there. Then you have a term outside. Then you can multiply in. Multiply in. So we do that. Then we'll end up with -1/6 of -6 minus 18x multiplied by this expression. Then there's a plus sign over here, so I write down a plus. 3 times of that same expression, 8 minus whatever, close bracket, then to the power of -12. I have not done any integration at all. I'm just doing algebra to make it in the correct format. So far, okay?
Yeah.
Now you got a plus. That means you can integrate term by term. So you can integrate the first guy. Just introduce an extra dx. Then you add on the second guy. Integrate dx. Is this part okay?
Yeah.
Integrate with respect to x. Integrate with respect to x. Okay, good. Now we have separated into 2 separate terms. Let's deal with this updated expression. This guy and that guy, the insides here, is it the derivative? Is the -6 minus 18x the derivative of the 8 minus 6x minus 9x squared?
Yeah.
Yes, already, right? So that means we are safe to use our reverse chain rule. So in this case, you can factor out -1/6 first, then you multiply by, integrate this one. What do you get? Fraction.
So 8 minus 6x minus 9x squared to the power of
Bracket.
half.
Power of -12 plus 1, which is a half.
Then over half.
Yes. Simplify. I'll just show the working -12 plus 1 in case you forget why it's a positive half eventually. Okay, here I don't put equal sign. Here I don't put equal sign. This is just intermediate working. And then finally I get my final answer, which is a positive half as the power and a positive half at the denominator. Okay, I also don't put the equal sign there. I just simplify straight away. When you divide by a half means you go up, then you become a ×2. Right? Dividing by a half is the same as multiplying by 2. Oh, so I just bring it up on top. So I have a -1/6 times 2, which will give me a 2/6 is 1/3. -1/3 multiplied by the expression to the power of half. Is that okay?
Yes.
Okay, good. So that's my final answer. Integral of this first term will give me 1/3 multiplied by 8 minus 6x minus 9x squared, bracket, power half. That is only with an extra minus sign. Sorry, with an extra minus sign. That's only the first term. We still need to deal with the second term, right? How do we deal with that? So let's rewrite it now as 3 divided by wait, let me think a bit. That's when you need to realize that this one is actually a standard integral. Here, if I rewrite my -half as a positive square root, but at the denominator, I'll get 3 over square root of 8 minus 6x minus 9x squared. When you see an integral of this format, where the square root, where you have a fraction and you have a denominator being the square root of a quadratic expression, you must look back at your formula list, your MF26. Square root at the denominator. Which one involves square root at the denominator as the f of x?
The sign one.
this guy here, exactly. So we need to force it to be following this formula, a square minus x square, right? Here I would, a square. I don't like a square. I prefer 1 square. Makes it easier to think about it. So maybe I'll just rewrite it in this format. So if I get 1 over the, let me think of it. Okay, let me see. If I don't want that a square, I want it to be a 1. Then this would mean I'll have 1 over square root of 1 square minus x square. You take the integral, you get sine inverse of x over 1. So I don't have to stress out so much about memorizing this, remembering to divide by a. X over 1 is just x. Okay, simplifies down to x. But now what happens if I replace my x there with a linear expression? So like for example, 2x plus 3 close bracket square. You just need to remember reverse chain rule. If you integrate something that's a standard formula and you get back sine inverse, but now the x gets replaced with a 2x plus 3, you just need to do an extra step. Similar to how integrating cosine theta d theta will give you a sine of theta. Maybe to be more consistent with the formula and help you see the pattern, I'll just replace with x. And if I replace the x with 3x, what happens? Is it still sine x? No, it becomes sine of
3x over 3.
Divide by 3. Additional division by 3 because of the reverse chain rule. So over here, if I have a x replaced with a linear expression 2x plus 3, I also need to introduce the extra divide by 3. So it's just sine inverse of copy down the expression 2x plus 3, then divide by derivative of the linear expression. It's just the gradient here, 2. Right, mx plus c, the gradient m. Okay. Yeah, I prefer this formula in this format where there's a 1 square, because I don't have to stress out so much about this division by a. Very confusing. I don't like that. Also, that's what we're going to do. We're going to force this constant to become a 1 square, which is just a 1 underneath a square root and minus something. So what you notice here is that there's an 8. You need a 1. Are you going to split it out as 1 plus 7? No, because there will be a plus sign here. So what's a better way? You must look back at this expression and you realize that, look back at the expression over here and you realize that, something bracket bracket square. Isn't that just a perfect square? Perfect square means we need to do a procedure. What's it called?
Huh?
What procedure when you see a perfect square like this? Complete what?
Complete the square.
Yes, complete the square. Add and subtract half the coefficient of x. Bracket square. Bracket square. Right? So that's what we're going to do over here. We're going to complete the square. So let's do it at the side. 8 minus 6x minus 9x square. Leave the, okay, this one, I don't like it when it's written with a negative coefficient. So I'm going to factor our negative sign first. Then I get 9x square plus 6x minus 8. Then what else? I also noticed that there's a coefficient 9. I don't like the coefficient 9 when I try to complete the square. So I'll zoom in first. Factor out the 9. So factor out the 9, I'll get x squared plus 6 over 9. Simplify, you get 2/3. X minus 8. Okay, in this case, maybe it's safer if I just rewrite it like this. I leave my 8 alone. Sorry for the confusion. Is this part okay? Here to here.
Yeah, can.
I leave the 8 alone, and then I factor out minus from minus 6x minus 9x squared. Then after that, I take out the 9 from the first 2 terms only. And then don't forget the plus 8. Then equals to negative 9 square bracket plus 8. Inside here, I try to complete the square. What would it be?
x plus 2/3 over 2.
Simplify straight away, you get 1/3. 2/3 over 2 is 1/3.
Then bracket square.
Bracket square.
Then minus 1/3 square.
Very good, exactly. Simplify it. Yes.
I cannot just like times negative for the whole thing. Cannot.
What do you mean?
Like the first step. Like I don't want a negative. Can I just times negative like the whole thing? Become like 9x squared plus 6x minus 8.
You can do that as well.
Okay.
Yeah, you can.
Okay.
Then later on you bring back the negative, also okay. I just prefer doing it this way. Yeah, then after that you can simplify this. You get -9 multiplied by x plus 1/3 bracket square. Then minus 1/3 square is actually minus 1 over 9. Multiplied by -9, you actually get a +1. Don't forget a +8. Right? Let's just double check with a calculator. -9 multiplied by a negative of 1/3 bracket squared, you get a +1. Yeah, definitely. Yes. Okay, then +1 plus 8 becomes a +9. Okay, so we get -9 bracket x plus 1/3, close the bracket square, +9. So far, okay?
Yeah.
The alternative way, I think what you are talking about is you just deal with 9x squared plus 6x minus 8, is it? Then you complete the square. You can factor out the 9, it's the same procedure. 6 over 9 is 2/3 x, then minus 8. It's just changing from a plus sign to a minus. Then you complete the square. You get 9 of x plus, divide by 2, you get 1/3 square, minus away that b square. Close the bracket, minus 8. Multiply in 9 multiplied by x plus 1/3, close the bracket square. 9 multiplied by -1/3 square is a -1 minus 8. Then you get 9 multiplied by x plus 1/3 bracket square, -1 minus 8 minus 9. So that's not the final answer because you started off by multiplying by a -1. So the actual answer you still need to multiply by a -1 to get back to -9x squared minus 6x plus 8 equals to -9 bracket x plus 1/3 square plus 9. Yeah. Like this. Okay? Can? So good. We completed the square already. So this guy, we're gonna sub back in over here. What do we have? Maybe before I even sub back in, I noticed that I'm just gonna do one extra line. I'm going to swap them around. Swap what around? Swap 9 and minus 9x squared, 9 and minus 9 bracket, whatever square around. Is this part okay?
Yeah.
So now I'm going to end up with the integral of 3 over, let me change the font size. Yeah, 9 square root of 9 minus away 9 bracket x plus 1/3, close the bracket square, dx. Can we use the formula already from MF26?
Cannot.
Why?
Must write like 3 to the power of 2.
Yes, correct. But in this case, I strongly prefer you to not write it as 3 power 2, but rather write it as 1 square. Force it to be a 1 square. How can we do that? How do we force this 9 to be a 1? And also notice that the coefficient in front of this bracket square is a 1. Here we got 9. Here we got 9.
Be 1.
Sorry?
It must always be 1.
Yes. Here must always be a 1 in front of the bracket. Sorry, I forgot to mention that. There's a 1 here. There's a 1 here. 1 times. So how do we make sure that you get a 1 square minus 1 times bracket square?
Factorize out like
Factorize out what number?
9.
9, exactly. Okay. So now you factor out the 9. Okay, I'm just gonna make this disappear. You end up with the integral of 3 over, factor out the 9, what do you get? You get 9 bracket 1 minus 1 times x plus 1/3 bracket square. Take the square root. What happens when you take the square root of a product? Square root 9 times square bracket. it just becomes the square root of each factor, like this. Does it make sense? Can see my, is it too thin? Maybe
Can see.
can see, okay. Can. So in this case, what square root of 9? It's just 3. What happens to the numerator and denominator 3? They will
Out.
cancel out. Left with a 1. So that means you're left with a integral of 1 over square root of 1 minus 1 times of x plus 1/3 bracket square dx. Then now you can just integrate safely. Straight away you will get sine inverse of x plus 1/3. Do you need to divide by a? In my formula, it is a safer and better world where you don't need to care about dividing by a. Just the x plus 1/3 is fine. The only thing that you need to divide by within the sine inverse, within the brackets, you don't need to divide by anything extra. Just copy and paste can already. But you still need to divide by the coefficient of the linear expression. Here is a 1x, so you divide by 1. Okay? Can now? Good. All right. Ken, do you want to try more practice examples involving sine inverse? Or we move on?
No.
No, Okay, then I move on. Ken, so now we can finish up the solution. So finally, the final answer will be negative of 1/3 bracket 8 minus 6x minus 9x squared to the power of 1/2. You can, if you want to, you can rewrite it as a square root. Both are fine. Then you add on. Yeah, it was a plus sign, add on. So yeah, add on sine inverse of x plus 1/3. What else is missing?
The plus c.
Very good, and that's your final answer. Okay. Okay. Yeah, so basically, complete the square. And then you try to make sure you factor out a 9 so that you get a 1 minus 1 times. Okay, Ken, let's go. Give me 2 minutes. I need to go and find some notes before I continue.
Okay.
And in the meanwhile, you can think about this. Hello.
Hello.
Hello. Okay, let's continue. So let me give you a list of all of the techniques of integration. Okay, I'm gonna list them down one by one. How to deal with integration. There's part A and a part B, and then a part C, and then part D, and then part E. Okay, there's 5 parts altogether. I'm just gonna list them down one by one. Okay, part A, standard functions. So what are the standard functions? You just refer to your MF26. Sometimes okay, not all available because some of them you already learn in O-level AMAX. Like for example, the first one, algebraic functions, they will not provide this one. Integrating one x power n, you already know how to do this. This will be x to the power of n plus 1 divided by n plus 1. Don't forget plus c. Next one will be, this is 1, this is 2. Integrating 1 over x, you also know how to do this. It's just ln of modulus of x. Don't forget plus c. Make sure you have the modulus here. Can?
Okay.
Can. Then next one will be exponential functions. Oh, just be consistent, use blue. Okay, you know what? Actually, I prefer black. Exponential, my favorite one. Why? Because it's easy. You just need to integrate the same thing. Ex dx is just the same thing again. Don't forget the plus c. But now if you generalize it to the integral of e power f of x dx, what do we get? You actually end up with, you are a bit difficult to integrate. So what you need is an extra f prime of x in front of it. Then we can use the inverse chain rule. We can just conclude it's e to the power of f of x. Because the integral of e to power x is still e power x, then plus b. Next one will be, oh wait, no, I should be consistent. I'm just following a formula list I have. Then number 4 will be the integral of a power x dx. This one is a bit special. You need to have a power x, but you divide by ln of a. The reason being, when you differentiate, like where can I write this down? Let's say, for example, over here, if we start off with y equals a power x, how do we differentiate this? A bit difficult. So we take ln on both sides. ln y equals ln of a power x. X bring down, you get x multiplied by ln a. ln a is just a constant. Then now you want to differentiate both sides. What do you end up with? You end up with 1 over y. I'll assume that y is positive, so I don't need to put modulus. It should be modulus here, but don't need. Then differentiate, you get 1 over y. Then this is really just ln of a. Oh, sorry, you're differentiating with respect to what? With respect to x. So that means that I still need to have my dy by dx tail because of chain rule. Right? Because y is a function of x. So you need a dy by dx tail. Implicit differentiation, right?
Yeah.
Okay, then now you can make dy by dx the subject by multiplying over by y. Ln a, you multiply by y. Make sense? Divide by y, bring over.
Yeah.
But what is y? What's y?
The a to the power x.
Exactly. So that means that the derivative of y with respect to x, in other words, d by dx of a power x, is just ln a times a power x. So if I want to integrate a power x, what happens? I just need to integrate both sides. Then after that, they will cancel off. I'm left with the integral of, the integral of ln a multiplied by a power x is just a power x. But if I just want a power x on its own, dx. Sorry, I forgot to put a dx. Oh, no dx here. Just to be complete, I should put the dx. dx. Yeah, what did I say? Yes, so therefore, if you want to find the integral of a power x, the ln a is just a constant. You can divide over. I'll get a power x divided by ln a. Don't forget the plus c. Can?
Can.
Yeah, so that's the formula. A power x is just like e power x, but you divide by ln a. Just imagine, imagine if a is equals to e, what do you get? Integral e power x dx equals to e power x over ln e. What's ln e?
1.
Exactly. So you're dividing by 1, which means that you're going back to e power x. Don't forget the plus c. Okay? Yeah, so this formula and this formula is the second formula is just a general version of the first one, where the A is replaced with E. Okay, don't forget the plus C. That's the long one. Then of course you also got the improved version where there's a f prime of x in front, and you take a to the power of f of x dx. It will just be a to the power of not x but f of x divided by ln a plus c. Okay, basically the exact same formula, but with an extra f of x, provided you have a multiply by f prime of x in the integrand, the part that is being integrated. Okay, then let me see. Right, I should also extend this 1 over x1. So I have integral of f prime of x times ln, not ln, 1 over f of x dx. This will just be ln of modulus of f of x plus c. Okay, next. Take note that this formula does not work. Does not work when n equals to -1. When n equals to -1, it becomes 1 over x, right? X power n is 1 over x. Then please use the second formula, ln of modulus x plus c. Can?
Can.
And remember that? Okay, that's the fourth formula done. Fifth formula, let's go. Oh, new component, new section. Not exponential anymore. Now it's trigonometrical functions. Trigonometric functions. Now there are a few categories to deal with. The first category, part I, will be basic. For the basic one, you got number 5. Number 5. This formula will be the integral of sine x dx. What is that equal to? Cosine x with a minus in front. Plus c. Sixth formula will be integral of cosine of x dx equals to sine of x plus c. Okay. Can? Then number 7. Let's put an asterisk over here. What does it mean? Integral of tangent of x dx. What is this equal to? Ln of modulus of secant x. What do you think is the modulus? What does the asterisk there mean?
Must memorize.
No. Those that don't have asterisk must memorize. Those that have asterisk is in the MF26.
Oh, okay.
Yes, correct. On page 4, look, integral of tangent x, you get ln of secant x. But actually it should be a modulus. Oh, modulus. Yeah. Okay, let's move on. So number 8.
Must have the modulus.
Yes.
Okay.
I think so. Yes, you need the modulus. Because for ln, you see, you cannot have ln of a negative number, right? So that's why you need the modulus. But if the x is restricted to a small enough region, small enough domain, then the secant of x will be positive. Then you don't need to put a modulus. Okay, provided the x is restricted. But in general, we just put the modulus there to make sure our ln is defined. Integrate cosecant, you get negative ln of the modulus of cosecant x plus cotangent x modulus plus c. Number 9, also asterisk, will be not cosecant, now it's secant x dx. In this case, it will be ln of modulus secant x plus tangent x plus c. Just here to take note, every one of these formulas, if the 1x is actually a 1x, right? If I change this to like a px, what happens? Everywhere else also need to change to a px. But reverse chain rule, what else do I need to do?
Times 1 over p.
Times or divide? We are doing integration here.
Times 1 over p, so it's
Oh,
divide.
sorry. 1 over. Oh, I didn't hear it properly. Correct.
Oh, okay.
Sorry, I didn't hear that properly. Yes, then you multiply by the 1 over p, divide by p. Okay, so I'm not gonna write the rest. You can do it yourself. The version where there's a p instead, just 1 over p, and everywhere there was x, replace with px. Okay, that was 9 star. Let's move on. 10 star. What is 10 star? You got the cosecant, you got secant. What's the last one that's remaining? No co. What's the last one?
Cotangent.
Cotangent, very good. So now we're gonna integrate the cotangent of x dx. Also in the formula, it's ln of modulus sin x plus c. Okay. Can Okay, now we move on to the squares. The squares. What does it mean when I say squares? It means that there's a power 2. So for example, integral of sine square x dx. Do you remember? I think you know how to do this. Remember the double angle formulas? Wait, let me check the formula list. Okay, it's already in the formula list. Like sine 2a is 2 sine a plus a. Cosine 2a is cos square a minus sine square a. 2 cos square a minus 1 and 1 minus 2 sine square a. Those formulas? Yes?
Yeah.
Okay, those are the double angle. You have to make use of it. So let's write down one of them. So cosine square, let's use theta. Sorry, I mean 2 theta. Should I just use the, okay, never mind. I just follow the formula list accordingly. Cos 2a is cos square a minus sine square a. Is equal to, if I substitute cosine square with 1 minus sine square, because sine square plus cos square equal to 1. Cosine square is 1 minus sine square, right? I'll end up with 1 minus sine square, which is 1 minus 2 sine square a. That's in the formula list. Likewise, I can substitute the minus bracket sine square a with a 1 minus cos square. Distribute the minus, you end up with 2 cos square a minus 1. Now, which formula is useful? 1, 2, or 3? When dealing with sine square?
The second one.
The second one is useful. You might argue, how come don't want to use the first one? Also got sine square, but here the problem is there's a cos square. You can make sine square the subject, but you'll still end up with a cos square. So the problem doesn't end. You still don't know how to integrate the cosine square. So, but if you use formula number 2, that's when if you make sine square the subject, you'll actually end up with integrate dx. Sine square x is actually 1 minus cosine of 2x over 2. Here we are using x, but of course it's the same if you change it to a. Or you replace the a with a 2. Replace the a with a x. Can? Can, good. So that is the integral. Then number 11. Next you got number 12. Integral of cosine square x dx. So same thing, you also end up with integral of 1 plus cosine 2x. Notice that now it becomes a plus sign. Okay. Do you want me to show you how to make cosine square the subject from here, the third formula? I'll just do it. Okay, so in this case, you have a cosine of 2a equals to 2 cos square a minus 1. So I can make 2 cos square a the subject. You will get cosine 2a plus 1. So that means cosine square a equals to 1/2 of cosine 2a plus 1. Which is the same as this guy. 1 plus cosine 2x over 2. 1 plus cosine 2x times half is divided by 2. Then you can do something similar with this one. Cosine 2a equals to 1 minus 2 sine square a. So I can make sine square a the subject. So 2 sine square a is 1 minus cos 2a. Make sine square the subject. I just divide by 2. So 1 minus cos 2a divided by 2. That's how I got this 1 minus cos 2x divided by 2. Okay. Yeah. Then from here, you can integrate. You know how to integrate this? there's a 1 minus cosine 2x over 2. It's like if you have 2 plus 3 over 7, do you agree that it's 2 over 7 plus 3 over 7?
Yes.
So if you can integrate this guy, you can integrate term by term as well. So now we got 1 minus cosine, it's the same thing. If I change this to a minus, does it help? You can split it up as what? 1 over 2 minus away cos 2x over 2. Then integrate term by term. Right? I'm sure you know how to integrate them. Yes? Okay, then I don't need to go through already. Just take note that there's a 2x here, so you need to divide by 2 again. Yeah, moving on. That is squares. Number 12. Number 13, we got integral of tangent square dx. This one is equals to, you need to use formula. Do you remember the 1 plus tangent square equals to secant square? Do you know this formula?
Yes.
Okay. Good. You need to use it. It's basically derived from the one of the Pythagorean theorem angles, properties. Like I'll just list it down for you. Sine square plus cosine square equals to 1. If I divide throughout by cosine square, that's what I'll end up with. Then if I divide throughout by sine square, I'll end up with 1 plus cotangent square equals to 1 over sine, which is cosecant square. A. I'm being lazy here, that's why I write s square and c square. Do you understand what I'm saying?
Yes.
Yes, okay, good. Then in that case, we can use the formula, substitute the tangent square with what? Here, 1 plus tangent square equals secant square, which means that if I just if I just minus 1 on both sides, I'll get secant square A, or rather secant square x minus 1 dx. Can I integrate secant square?
Cannot.
Can. Think about the derivatives. Differentiate what gives you secant square.
Is it in the MF26?
I don't think so. No. Really forget. Differentiate sine, you get?
Cosine.
Differentiate cosine, you get?
Or negative sine.
Differentiate tangent, you get?
Secant square.
Yes, it's not in the formula list. This one, differentiate tangent, get secant square. Must memorize. And then you need to know integral of secant square. This guy, you just get tangent x. Integrate minus 1, you get minus x. And okay, Okay, tangent x minus x plus c. Okay, moving on. That was number 13. Number 14. All these I never put asterisk means what? No asterisk means?
Must memorize.
Yes, but try not to memorize it wholesale. Memorize it with understanding. You're using what rule? You're using the double angle identity. By the way, this is something in general that we call power reduction. Power reduction. You see, whenever you got a power 2 here, or power 3 or power 4, okay, power 3, power 4 onwards will be for further math and H3 math already. You don't need to worry. Only H2 math, you only need to worry about power 2. Power 2 drop down to, you see, cosine power 1. Cosine power 1. Now you reduce the power. This is what we call power reduction, a fancy name to describe this. Once it's power 1, then we can proceed. It's linear, then we can proceed to integrate it. When it's power 2, we cannot. Okay, moving on. Cosecant square, how to deal with it? This one you must remember, it is cotangent. Negative cotangent of x plus c. This one no choice, really must memorize. I just went through just now, right? One of them. That was x over 2. I think I went through during lesson just now. No, number 15. Integrate secant square. Is it tangent? Yes,
Mm.
because differentiate tangent, you get secant square.
Mm.
Plus C, don't forget. Next one, 16. Integrate cotangent of square. Right, that's the last guy already. What would this be equal to? Remember the formula over here.
Mm.
What is it equal to? Cotangent square.
Cosecant square x minus 1.
Exactly. Then how do you proceed? How to integrate cosecant square? It's right over here. You get negative cotangent x. This one minus 1, you get minus x.
Mm.
Okay, then I don't write down already. Equals dot dot dot. Use the answer there.
Mm.
But don't forget there's a minus 1, so you also need a minus x and plus. Okay, can number 17. Oh wait, I need to write the category. This is now part 3. So far, what we have standard functions, algebra, exponential, trigonometric basic, trigonometric squares. Now trigonometric part 3 will be product. Product of trigo functions. So what formula do you need to use? Product to some formula. The P and Q one. The ones involving P plus Q over 2, P minus Q over 2. Those formulas. Okay. Yeah, so moving on. That was part 3. Let's move on to 17, product to sum. Well, there's a few you need to know. Over here, 17 and 18 is a bit funny. Notice that there's no asterisk. So again, it is not in MF15. Actually, let me just double check first. Hold on a second. Actually, I should put a blue color asterisk. Blue color star. It means that you can still use the MF15, but you need to be smart about it. You need to know that integration is the reverse of differentiation. So integrating secant x tangent x dx. Can you go to your MF15 and go and see where can you find secant x tangent x?
So secant x.
Yes, correct. It is just secant x, right? Because you differentiate secant x, you can get answer. And plus C. Okay, good. Then next one will be cosecant x. So remember, you can use your table of differentiation table of derivatives to help you to find integrals. So this will be negative cosecant, right? It's just using the formula list. Okay, with an extra minus sign, I just transfer over, multiply on both sides by a negative 1. This one is basically using the differentiation formula, differentiating of either secant x and the derivative of cosecant of x from MF26. Okay, that was number 18. Now moving on to number 19, 20, 21, then 22. This belongs to the same category. It's just using the product to sum formula, the P plus Q over 2, P minus Q over 2. I'll just list it down for you. I probably need more space for this. Okay, the first one will be integral of sine x cos y dx. It will just be equal to 1/2 of the integral of sine x plus y. Just sum the answers, sum the angles. The x here is P plus Q over 2, and the y here is P minus Q over 2. Sine of x minus y dx. Here, take note that there's a name for it. It's called factor formula. Okay, not useful. Remember it as the product to sum formula. It's more useful. We cannot integrate a product. When there's a trigo being multiplied together, product of trigo is difficult. We have to break it down into linear expressions. Sine of something, cosine of something, plus and minus. Yeah, so take note that here the x is more than y, and x is actually your p plus q over 2 in the formula list. Y is actually your p minus q over 2. The trick here is that p will be equals to big plus small, which is p plus q over 2 plus p minus q over 2, which is really just x plus y. And the Q here will be, I need more space. Hold on a second. Q will be big minus small, which is P plus Q over 2 minus P minus Q over 2, which is equal to X minus Y. Okay, that is your P and your Q. Moving on, number 20, we're going to integrate cos X sine Y. Dx. This one, or number 19 to 22, you can just use the formula list. It will be the integral of sine of X plus Y minus away sine of X minus Y dx. Next one, it will be cosine X times cosine Y dx. Notice I'm using small x here and this is capital X. Small x here. This is a variable. This x here is just a notation to denote some function of x that is really just your p plus q over 2. Then the y is your p minus q over 2. And then half times of cosine x plus y plus cosine x minus y. You're basically just using the MF26, but then you have to divide by the coefficient. You see 2, 2, 2, and -2, right, in the formula list, page 3. Then you just divide over, so it becomes half. Then this one, the last one will be -half. Yeah, so moving on to the last one with involving -half, it's the integral of sine x times sine y dx equals to -half times the integral of cosine at the angles x plus y minus away cosine x minus y dx. Okay, that is the 22 formulas. Not done yet. We are only at the trigo. We still have the next one. Now is part B, integration of products or modulus functions. Okay, let me start a new page. This will be part B, integration of, what do you call it? Products or modulus functions. Okay, so first one will be integral of f. Okay, I stopped the numbering already. Integral f prime x times f of x to the power of n dx is just reverse chain rule or inverse, same thing, chain rule. Okay, fx then power n plus 1, then you divide by n plus 1. Don't forget plus c. Next formula, if you're dealing with modulus functions, integral of a to b of the modulus of f of x dx, can you just type in the GC straight away? Can you just integrate it normally? No, you cannot. You need to sketch y equals to f of x, then split the integral. Okay, I'm gonna, how should I do this? Okay, I'll add a new page and then I'll start a new page and this will be the examples list. If I can just find a page. This one, I think it deserves an example because I haven't really gone through with you. Let's say you want to integrate -1 to 1 of modulus of x dx. What would this be equal to? What's the procedure? First step is sketch y equals to modulus x. So here's how it looks. It's really just positive x. This is called piecewise. Have you heard of it? Piecewise notation. X or -x. X when x is more than 0. -x when x is less than 0. What about when x is exactly equal to 0? You can use either formula. -0 or +0, they mean the same thing. So let's just arbitrarily say it's equal over here. Oh, do you understand this? X more than equals 0 means you get x. X less than 0 means you get -x. Y equals -x is here. Y equals to x is there. Okay? Okay, good. So now we have this guy. Then what do we do next? We want to find the integral from -1 to +1. Do you notice that there is this very sharp point over here? Like imagine you're on a roller coaster ride, very smooth, then suddenly, boom, you turn around and then you continue the ride. Very dangerous. This point here, very sharp point. This is a sharp point. So that's when we that once you notice that sharp point, you have to split the integral up. When you see -1 here to 1 here, what does it mean? It means you want to find area under the curve, right? So that means that you have to indicate here's -1, there's +1, draw a vertical line, draw a vertical line, area. Area. So that's what this question is asking you to actually do. Find the integral, then you split up the integral, right? That's the next step, split integral. Split up. Split up means you have to integrate from -1 to what's the x value over here? The sharp point, the x coordinate.
0.
X equals 0, so you integrate to 0. Can you understand? -1 to 0. Then what's the function here?
The negative x.
Negative x, so we put down -x dx. Add on integral, you must always continue. Your upper limit from the left integral and the lower limit from the right integral must be the same. 0 to what point? So what limit?
1.
1, exactly. You move from left to right. Then oh, by the way, if you swap it around, 1 to 0, you have to introduce an extra minus sign. When you work backwards, you end up with a negative integral. If you work forwards, then it will be positive. Forward means towards the right. Then integrate 1. What's the function over here? Y equals?
X.
Just x, so that's why it's just a positive x dx. Okay, then now you can go and find them out individually. Actually, do you realize that this is just a right-angled triangle, right-angled triangle?
Yeah.
So that means you can actually just find out the height, right? If x equals -1, negative x means you'll get a +1 here. So that means the length, close the bracket. That means the length here is 1, length here is 1. Similarly, you also get another length here is 1. And the length there is 1. I have no space, so I'll avoid writing it down. So this is really just 1/2 times 1 times 1 plus 1/2 times 1 times 1, which is just 1. No, is it? It's correct, correct. Yeah. It's just 1 unit square. Okay, that was an example. Moving on, that was how to deal with modulus, the simple example. Part C now, we want to deal with integration of fractions. This is the question you were asking me. How do you know you have to do partial fractions? Now I'm finally answering your question. Okay, so step 1, you should check whether the function is proper or improper. Let's write that down. Check if fraction, or rather what we call the integrand, the thing you are trying to integrate, integrate fx dx. This fx here is what we call the integrand. Can you understand? Okay, good. Now I'm just gonna shrink this down and toss it away. It's blocking my space. Go away. Okay, continue. Step 1 is to check if the fraction or integrand is improper or not. If it is, if improper, long division. If not, then do nothing. Leave it alone. So for example, if you got like for example, okay, you will have to end up with a final answer. Your final answer after you get after you do long division will be q of x plus r of x over d of x. Q is quotient, r is remainder, d is divisor. So an example of this would be you have to obtain q of x plus this guy after long division, or rather from long division. How an example for this would be, I'm just gonna give an example at the other page. 4x cubed plus 3 divided by 2x plus 5. Long division tells me that, oh wait, first you need to identify it's an improper fraction, right? Let's say for example we're trying to integrate this. Power 3, power 1, improper fraction. Yes. By the way, did I not define? Improper means degree of the numerator more than or equals to degree of the denominator. Oh, this one actually you learned before in AMAX, right?
Yeah.
Yeah. So in this case, let's say I have another example, integrate 2x squared over x squared plus 1. Is this improper or proper fraction? No, that was a question. That was a question.
Oh,
Is this an improper or proper fraction?
improper.
Improper because over here still equal. Power 2, power 2. Okay. Good. So let's just do an example. 4x cubed plus 3. I'll leave a blank space, 0x squared, 0x, and then plus 3 divided by 2x plus 5. How to deal with it? 4 divided by 2, you get a 2. X cubed divided by x, get x squared. So 2x squared. Multiply, of course, you will get back your 4x cubed. But you multiply by a 5, this one need to calculate 10x squared. Then minus bracket bracket. Subtract away 4x cubed, of course, it will go to 0. Don't need to write it down. 0 minus 10, negative 10x squared. Bring down the next guy, plus 0x. 10x squared divided by leading term 2x, what do you get? Negative 10 over 2, negative 5x. Multiply, of course, you will get back negative 10x squared. Multiply, you'll get a negative 25x. Bracket, bracket, minus sign, draw a line. Of course, you get a 0 over here. Don't need to write 0 minus 25 become plus 25. So 25x. Bring down the 3 plus 3. 25x divided by 2x. You're left with 25 over 2. Multiplied by 25 over 2. Of course, you get back 25x. Plus 5 times 25 over 2. That's 125 over 2. Minus bracket, bracket. Draw a line. Then now we can subtract 3 minus 125 over 2. I need a calculator for this. Negative 119 over 2. So your final answer will be the quotient 2x squared minus 5x plus 25 over 2. Then you add on a negative 119, the remainder, divide by the divisor, 2x plus 5. Is this okay?
Yeah.
Can or? Then integrating this will be easy because you can now integrate term by term. And then this guy, I think you also know how to integrate, just ln. Right? Okay, but this part sometimes is not so easy. Sometimes you'll still end up with a quadratic. Like for example, if here it was a 2x squared plus 5, wow, very painful. You have to deal with a quadratic at the denominator. And that's when that's our focus in this dealing with the fraction. I'll move on to step 2 now. Okay, this is our target in step 2. Previously, we are doing step 1. Step 1 is to check if it's improper, you do long division. Do long division. Then once we get this guy, we can deal with it using step 2 and 3 and some other steps. For the front part, it's quite obvious, so I'm not going to talk about it. Okay, you're just using x power n. Integrate become x power n plus 1 divided by n plus 1. The first formula. You know how to do this from AMAX already. Okay, moving on. Step 1 done. Now move on to step 2. Step 2 says that you have to now do LFP. Perform LFP. Basically, it's just a mnemonic for you to remember the 3 things you need to deal with. The ln formulas like the 22 formulas that I gave you just now, right? The 22 formulas, everything. Okay, from 1 to 22. Formulas means the 1 to 22. Then after that, P will be for partial fractions. Yeah. Let's see. Okay, for formula, it will also involve a few more formulas that I will be mentioning. Sorry, I need to make a correction. Sorry, formula does not refer to the 1 to 22. Sorry, I take that back. Formula is referring to 4 more formulas that you need to know that is available in the MF26. Okay, those involving the fractions. So let's just list them down. So L is for ln. So first you need to check if the integrand can be expressed as f prime of x divided by f of x. If it can, then straight away you can integrate this. It's a standard formula. F prime x divided by f of x dx will just be equal to ln of f of x plus c. Next one. Oh, wait. Sorry, correction. Not round bracket. Should be.
The square one.
No. Modulus. Make sure you got modulus. What square? What square?
Okay.
Huh? Confused? Okay, moving on. Okay, I draw a nice table for you. Next one will be F for formula. So what formula am I talking about? First, you need to check if the integrand can be expressed as a standard formula. I'm about to list them down. It's basically those formulas that you know from the MF15 for the integrals. So i.e. You need to check whether it is of this format, constant on top, divide by a quadratic. You know what's quadratic, right?
Yeah, the x square.
X square, yes. Function or expression. Or alternatively, it will be a constant on top, divide by the square root of quadratic function. Then in this case, when it's a quadratic, right? Let me just highlight this part and then I'll tell you, you need to complete the square. Okay. Then from there, you just use formula. So what are the formulas you have? Part 1, there's 4 parts to it actually. I'll put an asterisk there. What does it mean? Asterisk.
You need to memorize. It's in the formula.
Yep, exactly. MF26. Integrate 1 over square root a square minus x squared dx will just be equal to sine inverse of x over a plus, sorry, close the bracket first, then plus c. Now, I prefer the formula that doesn't have a square. So I'm going to give you an alternate formula. This one is not inside, not in MF26. So the alternate formula would be integral of 1 over the square root of 1 minus x squared will just be sine inverse of x over 1. Really, I'm just replacing the a with 1. I'm replacing the a with 1. Okay? Maybe I should write this down. Okay, sub a equal to 1 over here. Can see? A bit small. Can. So 1 square is of course just 1. A square is 1 square, which is just 1. So x over a is just x over 1. You get this simplified formula. And then you can generalize this into replace x with px plus q. Then chain rule tells me that divide by p. You have to divide by p. So what do I get? I'll get integral of 1 over square root of 1 minus something square equals to sine inverse of something plus c. But in this case, what is my c? Sorry. In what is my something? It will be px plus q, px plus q. So what else do I need to do when there's an extra p here?
Must divide by p.
Exactly, that's the formula. I prefer this formula. There is yet another alternate formula, which is to directly replace the x there with px plus q, but then later on you still need to divide by p. Oh, so basically x here replace with px plus q, then you need to divide by p. Same thing. What I'm doing here is maybe I write it down for you. Okay. The other formula would simply be, I will simply copy and paste this over. Okay. But then everywhere that had an x, I'm going to erase it. And I'm going to replace it with, I'm going to replace it with px plus q. Can you see?
Can.
And then you need to divide by P. Okay, that's all. All right. To be honest, I find it, I hate it. I really hate it when there's an a square over here. I strongly prefer it when there's a 1. Okay. I'll factor out coefficients just so that I can get my 1 in front. Easier for me. Okay, I really don't like this divide by a inside the argument. It's very, very funny. Very weird. Okay, moving on. So now let's deal with part 2. Part 2 is integral of, okay, I'll put a star there. Star there means is it inside the MF26. So integral of 1 over x squared plus a squared dx. Notice that here is a minus. There it's a plus. Plus, can you factorize or not? When it's a plus? Like x squared plus 2 squared. Is it x plus 2, x minus 2?
Oh, no.
No, it's wrong. Okay, only x squared minus 2 squared. Then you can factorize as a plus b, a minus b, x plus 2, x minus 2. Okay, moving on. So this is a standard formula. Just write it down. 1 over a tangent inverse of, they will give you x over a plus c. Again, I don't like my a, so I'm going to sub in with a equals to 1. So I will get integral of 1 over x squared plus 1 equals to 1 over 1 is just 1. Tangent inverse of x over 1 is just x. So easy. Then when I memorize the formula, I see, oh, okay, I don't need memorize that, but integral 1 over x squared plus something, straight away just tangent inverse. Just tangent inverse. No extra things hanging around here. Okay?
Can
you understand? But just you force this to be a 1. That's the only requirement. Force this to be a 1. Force this to be a 1. I don't like a square, I prefer 1. Then now I replace it with, okay, it's the same procedure. Replace, can I just copy and paste this?
Can.
Yeah, okay, faster lah. You get the pattern. So it's exactly the same. Replace x with 1 over with px plus q. So we're going to copy and paste this. Then everywhere that had an x, erase, erase, replace, change to blue pen, bracket, bracket, px plus q. Draw the line longer a bit. Px plus q. What else? Have to?
Divide by
P. Exactly. Huh? Okay, good. Then what else? There's a third formula, which is exactly the same formula that is in the formula list, but I don't like it because it's a little bit annoying with the a. I will now replace. Oh, that was a lot. Okay. Replace the x with a px plus q, and likewise over here. But what happens when you have an extra p? You still need to
divide.
Divide by p. Oh, okay. So it becomes 1 over ap. Okay. Well, ap is so funny. Very funny. I don't like it. I just prefer to remember it like this. With an extra 1, I will just get tangent inverse. Then if I replace my x with px plus q, replace x with px plus q, similar to integrating sine of 3x. Or integrate cosine of 3x. You get sine of 3x, but divide by 3. Here, you replace with x with px plus q, you just have to divide by p. It's like replacing with 3x plus 0, divide by 3. Okay, yeah. Moving on to part 3, another standard formula. What is part 3? Put a star first. Okay, this is integral of 1 over a square minus x squared dx. This will be equal to 1 over 2a ln of modulus a plus x over a minus x plus c. And there's also a fourth formula. Also inside the formula list, they simply multiply by a negative 1. So you get 1 over x squared minus a squared. Okay. And then you have to get 1 over 2a times the ln of modulus x minus a over x plus a. But wait, there's a condition. When you see a fraction, what can you at the denominator? It means you're dividing by something. What can you never divide by?
0.
Never divide by 0. So here a minus x cannot be equal to
0.
0. So means x cannot be equal to minus x bring over.
Cannot be a.
Not equal to a means two things, either less than a or more than a. Look at the formula list. What did they tell you?
This say more than.
More than a. What's the reason? If x is less than a, let's consider what happens if x is less than a.
But
Here,
won't it
x is,
just be negative?
huh?
But won't it just be negative?
Yeah, it should still work, right?
Yeah.
Let me think a bit. Why did they restrict it to be more than a? The correct thing is more than a. If x is less than a, then I want a plus x, so I'll get less than 2a on the numerator. And minus x will be minus a, but you flip the sign around, add on an a on both sides, you get 0, more than 0. So you get a negative, so you get a plus x to be less than 2a, and you get a minus x to be more than 0. Yeah, there shouldn't be anything wrong with it. But that's why let's not deal with the inequality. It's so confusing. I remember there was one River Valley question that I gave you involving differential equation that had to that where you couldn't use the formula. You're not allowed to use the formula because you didn't satisfy the condition of x more than a all the time. So that means I'm just gonna put down the condition here and the condition there in case you somehow want to use it. My strong recommendation to you is to not use these formulas and instead, whenever you see these formats, integrate 1 over a square a constant square minus x square or x square minus constant square, is to go on to the LFP. Remember LFP?
Yeah.
LFP, now is P. We move on to P for
Partial fractions.
partial fractions. We're going to use partial fractions instead. Let me make my table look nice. I'll just stretch it down. Okay, can. Then draw a horizontal line. Now it's P for partial fractions. P for partial fractions. So what we are going to do, we're going to check if the denominator, you know what's a denominator? The bottom part, downstairs. Denominator of integrand can be expressed in product form. You know what's a product, right? Product means something times something.
Yes.
In this case, basically, you already learned this before in AMAX. It's the 3 formats for partial fractions. And in this case, x squared minus x squared minus a squared minus x squared, it satisfies that format. You can factorize as I also didn't give you the px plus q form because I don't like this. My recommendation is use partial fractions instead. It's also quite fast. So this will be equals to num numerator divided by either ax plus b multiplied by cx plus d. Those are what we call distinct linear factors. Distinct and linear. Or alternative would be a numerator divided by what? Ax plus b, a distinct linear factor, multiplied by cx plus d, repeated linear factor. Distinct linear or this one is repeated linear. Okay. And then the last one will be numerator divided by ax plus b times x squared plus c. What happens here? There's a plus. Can we factorize as x minus square root c, x plus square root c?
No. Because it's plus.
Very good. This is wrong. Don't make this mistake. Instead, what is this equal to? This is actually equal to x squared minus 2. Minus with a minus, okay? Square root 2 squared. Okay, Ken. So those are the three formats. What else am I missing? Okay, that was step 2. Perform LFP. Oh, one more thing that is missing in this quadratic function. If you look carefully, among these 4 formulas, there's a square root a square minus x square plus a square. Oh, x square plus a square, then a square minus x square and x square minus a square. What you realize is that they are all quadratic and constant, quadratic and constant, quadratic and constant, quadratic and constant. Where's the linear term? What if you got something like 1 over x squared plus 2x minus 1?
Then complete the square.
Very good. You need to complete the square first. So let's complete the square. Let's just do with this example. Let's just do with this example. This is my example. So this example again. Don't bother writing example. You know it's an example. So let's try and integrate this. So first step is to complete the square. 1 over x plus, take half the coefficient of x, so 2 divided by 2 square minus away half the coefficient of x, bracket square. Lucky for me, the coefficient of x square here is a 1, so I don't need to factorize out the coefficient of x square. Easier to do the part completing the square. Don't forget the minus 1. dx. Continue. 2 over 2 is 1, so x plus 1 bracket square. 2 over 2 is 1, 1 square is just 1, so minus 1 is a minus 2 dx. Notice that this is just minus square root 2 square.
Yeah.
So what formula can I use? LFP. Is there a ln? There's a f prime x over fx? Definitely not lah. Is it f? A fraction? A formula? Yes, actually it's the x square minus a square format. But that's a part 3 and part 4, remember? These two?
Yeah.
But it's the x replaced with x plus 1. I didn't show you because I don't want you to do it. I want you to instead use
partial fraction.
Yeah, so do
it will
partial.
always work.
Yes, it will always work. Let me show you. Let me show you for this example. When you got something square minus something square, it's really just a plus b, a minus b, right? So a plus square root 2, a minus square root 2. Okay? Then we're gonna let.
Won't force me to use the formula. Like.
Nope.
Okay.
No space. Let me shrink it down. Equals to a over x plus 1 plus square root 2 plus b over x plus 1 minus square root 2. This is the what do you call it? Distinct linear factors. Okay, so you just multiply both sides by the denominator. You get 1 equals a times the minus version plus b times the plus version. Can? Okay, good. Carry on. Now we can sub x equals to, let's say, -1 plus square root 2. What a weird choice. Why did I do that? Because now I can see straight away. If I put in -1 plus square root 2, it will cancel off with the +1 and minus square root 2. I'm left with a 0. 0 times a. So I get b multiplied by x, in this case is -1 plus square root 2 plus 1 plus square root 2. Anything that cancels, -1 and +1. So you're left with root 2 root 2 times b. So that means that we get b equals to 1 over 2 root 2. How about a? In that case, we can sub x with, I don't know, what's a better choice now? What's a better choice now?
1.
1. I mean, actually, at this stage, anything can work out because we already solved for b. We already solved for b, so we sub in any value of x, we can solve for a. But 1 is not such a smart choice, you see. The goal here is we want to get rid of b so that we can isolate the a.
-1 minus square root 2.
Much better. Let's see if it works. 1 equals to a times minus 1 minus square root 2 plus 1 minus square root 2 plus b times, okay, yeah, I think by now you can see already. If it's minus 1 minus square root 2, it'll cancel off the plus 1 plus square root 2. So it's a 0. Very good choice. So you get a 0. It's gone. You're left with a multiplied by minus 1 plus 1 is 0. Minus root 2 is minus 2 root 2. That's a 1. So therefore a is equal to 1 over negative 2 root 2. Okay, good. Then we can just sub in. Okay, good. Then now we can integrate them. So copy. Sorry. Okay. What is happening? Did I not copy it? Copy, paste. This guy, very small. Let me just expand it and make it look nicer. Integrate dx equals, can?
Okay.
Okay, now I'll just shift it to the left to save some space. Sorry for the presentation. Yeah, I'm trying to save some space. Oh, okay, can. So 2 root 2, then now you just have a 1 over x format, right? How to integrate this? You can factor out the pink color 1 over negative 2 root 2. Okay, maybe I'll be consistent. I'll use pink color. And then you multiply by the integral of 1 over x plus 1 plus square root 2 dx. And then you add on, again, another pink integral, but this time it's a positive version. Then you integrate all this. Oh, cut and paste faster a bit. Do you get what I'm doing? I split up into term by term. I integrate term by term. Then I factor out the pink color factor. How do you integrate 1 over x?
It's ln.
Yeah, so 1 minus 2 root 2 ln of modulus x plus 1 plus square root 2 plus 1 over 2 root 2 ln of modulus x plus 1 minus square root 2. I think once you practice a few times, it's actually quite fast. Way safer than using the formula. Okay, then now you got a plus, you got a minus, right? You got a minus over here. How do you combine into a single ln? Oh, so
Can
they
divide with the minus.
what over what? It'll be a fraction, right?
Is the x plus 1 minus square root 2 over the x plus 1 plus square root 2
Something is missing.
plus c.
No, not just that. Here I go and take negative ln and then positive ln. Who did I leave out? Who did I leave out?
The 1 over 2 square root 2.
Exactly. So what we need to do is to actually first factorize out the blue color 1 over 2 square root 2 first. Yeah, so thin. Let me change the font size. Okay, and then we get ln negative ln plus ln of whatever. Then here I'm just gonna write down plus c. Don't care. Technically I factor out. Then the c may be a factor. Oh wait, actually the c is not a factor. So just leave the c alone. Just write down a plus c all the time. Okay. Then after that, this one combined, you get a positive term on top, then the negative one below. And then in the front, you get a 1 over. 1 over 2 root 2. Answer. Okay. Okay, you could have used the formula and you get the same result straight away, but I'm a bit afraid of using the formula. I prefer doing it through partial fractions and then do a bit of logarithm rules. Okay. Oh, one note is that some questions they may say express your answer in the form of this guy. They'll say express your answer in the form of 1 over a square root b ln of modulus of x plus p and x plus q. And then they ask you to find out what is a, b, p, and q. So they'll force you to write down in this format. So using partial fractions is okay. They won't force you to use formula. Okay, you can use partial fraction. You just need to be flexible. Positive ln, negative ln. The positive one goes to the numerator, negative one goes to denominator. Okay, that's just using logarithm rules. If you recall, ln A minus ln B equals to ln of A over B. Here it's just rewriting the ln A minus ln B as negative ln B plus ln A. Right? Negative ln B plus ln A. Sorry. Can Okay, that was an example. Moving on. That was step 2 only. Let's recap what we have done so far. Our roadmap, 5 parts, A, B, C, D, E. Part A is standard function, algebra, exponential, trigonometric. Trigonometric got a lot. Then after that, step B, got A, B, C, D, E. Now it's part B, integration of products or modulus functions. Only 2 formulas. This one is easy. Modulus must draw picture, then after that you split at the pointy ends, or when it actually cuts the x-axis. I haven't thought about it some other time. Then integration of a product will be this one, inverse chain rule. Maybe I wrote down over here already. Then now part C, integration of fractions. Yes, 2 steps. Actually there's just 2 steps. Step 1 is check if it's an improper fraction or not. If it is, you go and do long division. I showed you just now. You'll eventually get to qx plus rx over dx. Right? Look at this example here. This is qx. Maybe I should have labeled this. Sorry. This is qx minus negative 119 is your rx. 2x plus 5 is your dx. Clear so far?
Yeah.
Then you deal with your rx over dx. Oh, I forgot to mention that. Sorry. We deal with rx over dx. It will confirm be a proper fraction because of the way that the long division works. It will be a proper fraction by step 2. Okay? So that's when we talk about step 2. What is step 2? Step 2 is LFP. Perform LFP. So basically, you have to check this fraction now, rx over dx. Because this is called integration of fractions, so we always have a fraction. Use the ln formula, or use standard formula, or use partial fractions. For ln, you check whether you get f prime x over f of x. For if you have the f prime x over f of x, what do you call it? Form. Whether your fraction is in the form of f prime of x divided by f of x. If it is, then you just integrate it straight away to get ln of f of x modulus. Right. I should mention this trick. Over here, if let's say you got 1 over, I should mention this example. Sorry, this is an important example. X squared plus 5x minus 3. And then on top you have, let's say, 4x plus 10. Okay, maybe plus 9. Then what can you do? What you can do is you can factorize out. You can rewrite it as, okay, no. You need to identify that your f of x is the denominator, x squared plus 5x minus 3. Okay, you know what? I'm not gonna do this over here. I'm gonna do it as an example. Sorry, let me just try this example. Over here, let's say that we are trying to integrate this fellow. Definitely is a proper fraction because numerator is power 1, denominator power 2. So we're gonna first identify that the denominator x squared plus 5x minus 3 can be f of x. So f prime of x will be what? 2x plus 5, yes?
Yeah.
So now what we want to do is to make sure that the numerator is 2x plus 5. If the question was 2x plus 5 divided by x squared plus 5x minus 3, wow, so easy. Straight away you can integrate, right? It's just ln of the modulus of x squared plus 5x minus 3. Yes?
Yeah.
If only. So here's a trick. Remember, I went through just now that question. 4x plus 9 can be transformed into 2x plus 9, 2x plus 5, because they are both the same degree. Power 1. Usually, it's just power 1. Then how can we do that? What we need to do now is, usually, sometimes the questions, they will give you a part 1 to hint to you. Part 1, they'll ask you to show. No. Find the values of A and B such that, ST means such that, 4x plus 9 can be equals to A times of 2x plus 5 plus B. This is a standard trick. Okay, standard trick. I I'm writing it as an example because it's not exactly relevant to my summary. So it's just an example, and it's a standard trick you should memorize. The question may not give you a part one. Sometimes they are kind, they will give you, sometimes they won't. You need to know this trick on your own. So here you realize that A can actually just be 2, right?
Yeah.
Because you have 2 multiplied by 2, you get a 4x. But what happens if it's 2? 2 times 2, you get 4x. 2 times 5, you get 2 times 5, you'll get
10.
10. Yes, I'm waiting for you to like 10.
Oh.
Then, but here is 9. How do you go from 10 to 9? What do you think?
+1.
Plus 1, so 10 plus 1, 11.
Minus.
Minus 1, B should be a -1. Let's double check. Let's double check if it's correct or not. So A is 2 and B is -1. So substitute them into A and B respectively. So plus a -1 is just -1. Multiply out 2 times 2, 4x. 2 times 5 plus 10, -1. Do you get back to 4x plus 9?
Yes.
Good. So that means you got your A and B already. So that means that you can now rewrite it as 2 times of 2x plus 5 minus 1 on the numerator divided by the denominator of x squared plus 5x minus 3, integrate with respect to x. Then you can see something minus something over a denominator. You can split up, right, into 2 fractions. The first fraction here, minus away the second fraction there. Copy and paste the denominator. I copy, I paste. I paste. With an iPad, I can do things a bit faster. But of course, manually, you have to write it out. Can? Can. Okay, good. Then not done yet. So maybe I should mention may not be hinted by in A levels. They may not give you this part 1. And then part 2, they ask you to find the integral of 4x plus 9 over x squared plus 5x minus 3. They may not give you this hint. Okay, so now we can go back to the solution now, over here. We can ignore the working before already. Just deal with this. How do you integrate this guy? I notice there's a 2 here. Let's just take it out. So this will just be equal to 2 times of the integral of this bunch here. Sorry, I forgot to put dx. No. Oh, sorry. Yes, I'm correct. Integral of dx. Yeah, I haven't split up yet. You know you can split up, right? Term by term. Integrate term by term.
Yeah, can.
So I can integrate dx, and then I add on integral of negative whatever dx. Of course, you can take out the minus straight away. So that means you'll be left with a minus in front. Then integrate 1 over whatever dx. How to integrate this guy? Sorry, my handwriting. That's a 2x plus 5.
Is ln.
Yeah, very good. Because this is fx, this is f prime of x. So you just get ln of modulus of
the x squared plus 5x minus 3.
Yeah, don't forget to write the 2x 2 times in front. Then minus away, integrate this one. Now this is a problem. What do you do? How do you deal with this? You got quadratic at the denominator. You got 5x in the middle, odd 1 out. LFP, which one? Can you use L?
No.
Is it f prime x over f of x?
No.
So can we use f? Formula?
Yes.
Cannot. You see the formula, it says like square root a square minus x square. Don't have a linear term x. X square plus a square minus x square minus a square. Don't have it?
I can complete the square.
Exactly, very good. Complete the square. You need to make sure you complete the square when you have a linear term here. So I'm not gonna do it. Actually, let me just double check. This example I gave you. I didn't plan properly. I just come up with a random example. Okay, this one got 2 real roots, 2 distinct roots, means I can let me think a bit. Minus. It will be a minus. Have I dealt with minus already? I'd already dealt with minus. Okay, that's not a good example. I want to have a plus. Okay, that's a bad example. Okay, then this one I don't want to go through. because it's exactly the same as the previous working. Okay, it's just that the numbers are a bit more complicated. Okay, then you can do the rest on your own. Can I just try one more example with you? Let's try another example. Let's say it's integral of, I still got part D and part E not done yet. Oh my goodness. Let's deal with this one. Let me think. B squared minus 4AC. Let's say I put a 1x. I'll just put a 10. Okay, confirm can already. How do you deal with this integral? First step, is it step 1 is to check, is it a proper fraction or not?
Yes.
Proper? Do you need to do long division?
No.
Long division? No need. Okay, good. Then step 2, LFP. Is it the L? Is it f prime over f of x?
No.
No. So you skip. Then you go on to f. Is it a standard formula?
Yes.
But there's an x here. What do you need to do?
Complete the square.
This one, yes, complete the square first before you can use the formula. Okay, complete the square first. So let's do that. So this will be equal to 1 over x plus 1. There's a coefficient 1 here. You know that. Okay, should I make your life difficult and put a coefficient 2 here?
Sure.
Okay, let's just do that for demonstration. Factor out the 2 first. So factor out the 2, you're left with x squared plus, I usually do not factor out from the constant. So I'll be left with half x, then plus 10. I just keep the 10 alone.
Oh, okay.
Oh no, I decided to commit to the integral 1 over dx. That means I have to keep on copying down while completing the square. Very painful. I'll just demonstrate to you how to do it. Okay, but this procedure, this thought process you don't need to write down. Just think inside your head can already.
Yeah.
I'm just gonna skip the thought process and just do it. So yeah, then just continue integral dx, complete the square 1 over. Let me copy and paste this so I don't have to keep on writing this out. Copy. Okay, use it later. So 2 bracket. Now we can complete the square. So x plus, take half the coefficient of half. That's 1/4, right? Close the bracket, square, minus away that same number, half the coefficient of x, square. Don't forget, close the bracket. There's a 2 that was factored out from this pair of bracket. Maybe I make it extra thick so you can remember that the 2 is only applied to the first two terms. Okay, this is the completed square version. But it's not applied to the plus 10. So leave the plus 10 alone. Do not multiply 2 to the 10. Leave the 10 alone. Carry on. I can just copy paste. Sorry. Paste. Wasting your time. If I do that. Okay, so now that you have this format, you can multiply in. You get 2 multiplied by x plus 1/4 square. 1/4 square is what? 1 over 16 with a minus in front, but you multiply by a 2. Isn't that just negative 1 over 8?
Yes.
Negative 1 over 8, then you have to add on a 10. Remember the plus 10 there? So what's 10 minus 1 over 8? Use a calculator. 9 and 7, 8. Okay, I need to use a calculator for this. Minus 1 over 8 plus 10. I strongly prefer improper fractions. So I'm going to write down plus 79 over 8. Yes?
Yes.
Okay, good. So what do you see here? What's the sign here?
Plus.
Okay, I'm going to copy down the F page. Then you tell me which formula do you want to use? What, part 1 or part 4?
Okay.
Which one?
The second one.
The second one involving a plus. Now I'm just going to use my formula, which is my trick, which is to always make sure my constant is a 1. So I also sorry, I forgot to mention this. The coefficient of x squared is also a 1. Okay, or bracket px plus q square, there's also a 1 in front of it. So over here there's a 2, over here there's a 79 over 8. Wow, how? How to deal with it? Okay, let me think a bit. Maybe it's not so good to always keep the 1 over here, but not divide by 2, factor out a 2 from the denominator. So I'll be left with x plus 1 over 4 square plus 79 over 16. 1 over. Is that okay?
Yeah.
Sorry, this should be a square. Can? Okay. Let me just crop this down so that I only have the relevant part here. Just bring it down, and then I continue. So over here, I can just factor out a half first, then I'll integrate the rest. So far, okay?
Yeah.
Okay, good. So now we are going to get rid of the square bracket. So now I think, sorry, I was wrong. I shouldn't just always keep it as a 1 square. I have to keep it as an a square here. Then I can use this formula. No choice, no choice. I have to use this formula. If only there was a way to avoid it. Let me think a bit. Is there a way to avoid having to divide by a 79 over 10? So irritating. Let me think. How do I make this a 1? If I factor out an extra 79, I'll have an extra 1 over 79 over 10 here, which will make my life also quite difficult. Oh wait, it works. I can do that. Okay. Can. So here is a way that I can simplify this. It's about to get quite ugly. So please bear with me.
Okay.
X plus 1 over 4 square plus 79 over 10. Here's what I'm going to do. I mean, I wish for it to be in the format of px plus q square plus 1 square. Okay, I want it to be like that. How can I force it to be equal? What I can do is 79 over 10, I want to make it into a 1. 1 square is just 1. So what I can do now is I can factor out 79 over 10. Okay? What am I left with? It's 10 over 79 times x plus 1 over 4 bracket square plus 1. Yes?
Yes.
Okay. Actually, you know what? Let's not even bother factoring out the 2. Let's not bother factoring out the 2. I'll just start with the original. Okay? From here, I'm going to force it to, there's an extra 2 here, 79 over 8. I'm just going to force it to be this format, px plus q bracket square plus 1. All right? There's a 1 in front here as well. How do I do that? I can factorize out 79 over 8 in this case. Sorry for the abrupt change. Are you following? So I restart this one. I go back to 2 times of bracket x plus 1 quarter square plus 79 over 8.
Cannot factorize out like a half. Then it becomes 79 over 16.
16, right? Oh, wait. I think I write down wrongly. Just now it should be 16. Yeah. I can, but I don't want to do that. I'm going to do it a bit faster.
Okay.
Because the half is not much difference. So let me show you how I can do it. I'm going to convert this denominator into this format. I'll try and find out what is P and what is Q. Please don't go and expand this. Don't expand this. Very, very slow. I show you a way to get the P and Q a faster way. So let's do that. So over here, I see 79 over 8. I see what I want, which is a 1. So I have to divide, or rather I factorize out 79 over 8. That's what I do over here. Then that means I'll be left with 8 over 79 here. Right? Then here will be a 1. Correct so far? Good.
Yes.
Then 79 over 8, I'll leave it alone, multiply. Then over here, 8 over 79. Do you agree that it's really just square root 8 over, okay, or rather, it's just square root of 8 over 79 square?
Yes.
Times the rest. So if you got a square times b square, isn't that just ab bracket square?
Yeah.
So that means I can bring it in. So square root 8 over 79 times x plus 1 over 9 bracket square bracket plus 1. This is a, sorry, this is a, that is b bracket square. Clear so far?
Yeah.
Simplify 79 over 8, no choice. I have to keep on tagging along. I'm going to get rid of it later. So now you just have square root 8 over 79 times x plus square root 8 over 79 times 1 over 9 bracket square plus 1. Clear so far? I just multiply in. Okay, then now I can transfer over. Copy and paste it over here. I will be left with 1 over integrate. Are we clear so far on this? I
Yes.
haven't done any integration. I just replaced the denominator with this. Now you got 1 over 79 over 8. Can you factor it out? Yes, you can. Can you see what's going on?
Can.
Okay, let me just graft it over here, like skin transfer. Wow. Grafting. Okay, can. Done. What's my P? What's my Q? Do you see that it's the same format now?
Yeah.
What is P?
The square root 8 over 79.
Good. And what's my Q?
The square root 8 over 79 times 1 over 9.
Yes, very good. Okay, exactly. Then from there, you can integrate. So now, 1 over 79 over 8 is nothing but 8 over 79 multiplied by integral of P plus Q squared plus 1. Look at this formula, P plus Q squared plus 1. It's just tangent inverse, isn't it? Just tangent inverse. But then you copy and paste whatever is inside, then you divide by its coefficient. So that's what we're going to do. Now it will just be equal to tangent inverse of copy and paste whatever is inside. And then I divide by 1, multiply by 1 over P. In this case, what's P? Square root 8 over 79 plus C. Done. That's it. Don't need to worry about dividing by a coefficient of something. Because of my formula, I force this to be a 1. Okay? Then you can simplify this a bit. Let's just simplify 8 over 79 multiplied by 1 over square root 8 over 79 is really just square root 79 over 8. Simplify a bit. This is square root 79 over 79 times square root of 8. 8 cancel off with square root 8. You're left with a square root 8 on the numerator times square root 79 over 79 is already rationalized. So we can leave it alone. Don't cancel off anything. 8 times 79 is just 632. So we can leave it as square root of 632 over 79. If the question was evil and they ask you to leave your answer in the form of square root A over B times tangent inverse of Px plus Q plus C, some arbitrary constant C. Then they ask you to find A, B, P, and Q. Then you really need to simplify into this. They may also say A, B are rational numbers. Rational means fractions. Rational means can be expressed as a fraction. You don't need to leave it as a fraction. 632 is a perfectly rational number. So A equals to 632. Then B equals 79. Also, final answer will be equals to square root 632 over 79 multiplied by tangent inverse of copy and paste. Whatever was there. Copy and paste it over here. Done. Can?
Can.
Okay, that still not done. I'm gonna continue. Okay, so that was my step 2. Remember there was A, B, C, D, E? A, B, C, D, E. A is done. B is done. C is done. Integration of fractions. Still got D and E. Let's go. Let me add a new page. Hold on a second. Piecewise. Examples page. I don't want. I want to add a new page before the examples. Okay. Where were we? Part C is done. Now we move on to part D. So what is part D? Integration by substitution, which is your next exercise, question 7 onwards. You haven't do it yet. Okay, integration by substitution, there's really just a few things you need to do. Start off with integral from x1 to x2 of f of x dx, right? You're going to transform it into something simpler by introducing a parameter called u. u1, u2, then this will change the function into a g of u. Then you multiply by dx over du times du. So really the procedure goes in 3 steps. Step 1, you eliminate x. Basically, you sub the f of x, the original function in terms of x, with something that's in terms of u. Step 2 is you have to eliminate the dx. How do you do that? You have to take your u equals to f of x. U equal f of x. Then you differentiate. It's a bit like differential equation. So you get du by dx equals to some f prime of x. Then from there, you can make dx a subject, right? This is technically not correct, but I'm gonna put approximately implies that du is equal to f prime of x multiplied by dx. Then from there, you can sort of make the dx a subject, and then you can sub in, right? You see the dx here? See the dx here? You try to sub in. Maybe if I just make it even funnier, du over f prime of x equals to dx. Take note that sometimes you may still need to replace the f prime of x here with something in terms of u. Like classic example would be, let's say you let u equals to e to the power of 2x. Then du by dx is what? 2e power 2x. So that means that this is really just du by dx equals to 2 times of u. You understand that? E power 2x here is the same as the original thing you are trying to integrate, so you can replace it with a u. Then from there, you can get du equals to 2u dx. Maybe it will be useful. I'm not sure if it's useful or not, replacing it with a u. I'm just telling you it's an option. Okay. You have to see case by case. Step 3, step 3 is also simple. You just need to change your limits. If this was what we call a definite integral, step 3 is optional, only applies to definite integrals. You have to change what? Change the x limits to u limits. Make sure that you don't blah blah. Upper is upper, lower is lower. X2 goes to u2, x1 goes to u1. Don't blur like sotong. Please don't mix it up. Okay, I better not use double negative. Be clear like the sun. Be clear like the sun. Upper limit stays as an upper limit. Wow, this is the most useless sentence ever. Upper stays as upper and lower limit stays as the lower limit. Some students are very blur. They will mix it up. Like for example, if you have x equals to square root, upper limit is x2, integrate some fx dx. And x1 equals to 1/2. And then you let x equals to sine of theta. You introduce a theta. Then upper limit here will be what? X equals to square root 3/2, which implies root 3/2 equals sine theta. Then that implies that theta is equals to pi over 3, 60 degrees. And x equal to 1/2 implies that 1/2 equals to sine of theta, implies that theta equals to 30 degrees, pi over 6. So who is the upper limit here? Is it pi over 3 or pi over 6?
The pi over 3.
Exactly. So I predict that you will be blah blah, but I'm trying to prevent it. That you put down pi over 6 on top and then pi over 3 below. Wrong. What's wrong? Upper limit is root 3/2. Lower limit is pi over 6. Don't blah blah. Be
So
clear like the sun. Be
larger
clear.
and bigger lah.
No. Upper limit is on top. Lower limit is below. Not big or small. Sometimes the upper limit could be a small. And anyways, pi over 6 is smaller than pi over 3. In this case, it's just a coincidence that a pi over 3 is bigger and pi over 6 is smaller. Just a coincidence. You're supposed to stay as upper limit stay as upper limit, lower limit stay as lower limit. So one way that I can help you to prevent this careless mistake, right, is to make sure that your upper limit you write on the top line, your lower limit you write on the bottom line. Okay, so yeah, make sure it's one on top, one below, so that you don't get confused. Or if you need more space, then you just make sure the lower limit you write far, far below, so that you can know, oh, on top means it's upper limit, so I must transfer on top. Lower, it's at the bottom of the line, so it means we must stay at the bottom. All right, don't blah blah. You better make sure your limit you don't mix up. Okay, good. Then after that you get your G of U du. Okay, yeah. Okay, that was substitution in general form. It's a bit confusing without an example. So let's just go to one of the okay, I won't give you the solution yet, but I'm just gonna go through one of the examples. Question 7. Let's just go through part A lah. Let's look at question 7, part A. Hide the answer first. Okay, I'll go through question 7A at the top here. You have the integral of e power 2x divided by e power x. Then you add on a 2dx. They tell you the substitution. Oh, by the way, A levels nowadays, like from now onwards, will always give you the substitution. Okay, this will always be given. Don't worry. U equals to e power x plus 2. Well, but sometimes they will ask you to integrate like sine inverse of x. Then that's when you need to use part E. I haven't talked about it. You must have an invisible 1 times, and then you need to use something known as IBP, integration by parts. Okay, integration by parts. Yes, I'll talk about it later. Need to introduce yourself. They won't give you a substitution. But this case, this is a substitution question. Let's deal with the substitution. How do we deal with it? So let me just screenshot the procedure. Hold on a second. There's really just 3 steps. Very easy. Don't worry, don't worry. Okay, shrink it down. Put it at the corner to remind you. Okay, step 1 is to eliminate the x. So what you see here is there's an x, there's an x, there's an x. But here you want to use u. So what can you do? Notice e power x plus 2. Anything similar?
Yes, the denominator.
So now you can replace it with integral of denominator. So it's just a u dx and e power 2x. Is that okay?
Yeah.
Wrong. Step 1 helps you eliminate x. You still have x here, you still have x here. Wrong already. Cannot continue.
Oh.
You must continue to replace everything in terms of u. E power 2x, e power x. How can you link? How can you rewrite the e power 2x in terms of u? In terms of u. How?
U minus 2.
Okay, so let's work it out. So u minus 2 equals to e power x. Can we just sub in with u minus 2?
No.
Then how?
How?
E power x, e power 2x.
Can it become like ex to the power of 2?
Yes, it can. That is correct already. Yes. E power 2x is actually just e power x squared, right? Because when you got a power exponent raised to a power, you just multiply the powers together, which is e power 2x. So you square on the right side. What do you do on the left? Is it u square minus 2 square? Yes, no?
No, it's the whole thing square.
Very good. You didn't fall for my trick. Well done. U minus 2 whole thing square. Make sure you got that. So now that we have e power 2x is u minus 2 bracket square, we can replace the numerator with
the u minus 2 square.
Yes, correct. Okay, then still got dx, can or not? Can we continue?
Cannot.
That one says what? Eliminate x. No traces of x can remain. Here got u, here got u, here still got x, very bad. No evidence of x must remain. What do you do?
Must replace with du.
Yeah, in terms of du, expression in terms of du. Yes. So how do you get the du?
Differentiate u.
Exactly. So you get du by dx equals to do it now.
The e to the power x.
Plus 2,
Don't have.
Very good. Yes, correct. Okay, then now you have dx over here, but you have dx at the bottom. So you just make dx a subject. So du equals to e power x times dx.
Mm.
Then after that, you can make dx a subject, sort of. So it's 1 over ex du. So you're going to replace it now. Integral of u minus 2 bracket square over u. Dx is 1 over e power x. Do you know how I get 1 over?
No.
Oh, I don't understand. Okay, I slow down a bit. Basically, here is multiplying, right? Okay, maybe I rewrite it. E power x times dx equals to du. Make dx the subject. You got multiply by e power something. What do you do to get rid of it? Bring
Divide.
over. Opposite of times is divide. So that's why I have a 1 over. Understand now?
Oh, okay, can.
Okay. I think I got this is a common problem with students. You want to make something the subject, you need to make sure it's on the left side so that you can see it clearly. For me, I'm experienced already, so I know how to make it a subject straight away. But maybe, okay, I'll keep that in mind. Make sure that the thing you're trying to make the subject, keep it on the left-hand side first. Then after divide by e power x. I think that's easier to see, right? For you? Yep. Okay, can. So now, anyways, you got 1 over ex, then du. Is that correct? Yay, my x changed to u. Can I now integrate? Step 1 done already? Eliminate x?
But there's still the ex.
Exactly, very good. You didn't fall for the trick. There is still an x. Oh no, then what do we do?
Replace with u minus 2.
Very good. Yes, exactly over here, right? So we're going to replace it with u minus 2 before you carry on with the integration. If you don't do that, you cannot, it just won't work out. But take note that it's multiplied by 1 over, you can't see, 1 over e power x, which is u minus 2 du. Finally, we can proceed. But before that, notice that u minus 2 square and u minus 2, common factor of u minus 2. So I can actually cancel them off. Simplify it to 1 over u du. Wow, 1 over u du, so easy. How to integrate? 1 over u power n equal -1.
Cannot integrate like normally though.
I show you. You get a 0. Yes, remember, -1 does not work when n is -1. So you have to
use the 1 over x.
Which is? Hey, read it. I circle the answer for you already.
Ln modulus x.
Yes, ln. 1 over x, you integrate, you get ln. But of course, here is a u. We are transferring to the u world. At first is the x world, x. Now is u. Everything is u. Okay? Must know this idea. Previously was the world involving x. Now we transfer to another dimension. We go to the u world. Make sure you're in the u world first. That's really just my step 1. Eliminate x. Okay? Yeah. So there will always be this problem like with 1 over e power x. You have to again substitute back with a expression in terms of u. You cannot just differentiate. It's not good enough. Okay? You still need to replace the 1 over ex with 1 over u minus 2. Okay, then finally, so therefore this is ln of modulus of u plus c. That's our answer, yes?
Yeah.
Wrong. Let's look at the procedure. Okay, eliminate dx done already. That's good. Step 3 we skip because there's no upper and lower limit. It's not a definite integral. And yes, correct. You must answer the question when they start off with x. Your final answer must be in x. So we must start back with ln of modulus of. What's u?
Ex plus 2.
Very good. So maybe I will just improve my notes were not good enough. I have to tell you because you will forget. You trusted me when I said so. That's the final answer. Wrong. I cannot leave in terms of you. Must start back with. Okay, maybe I should mention step 4. Step 3 you skip if it's not a definite integral. Step 4, replace u with the substitution with x. how do I say this? If we let u equals to f of x, right? So we need to replace u back with f of x. Okay? Can it's a similar idea to like when you're solving. Let me give another example over in this page. Like for example, if you are dealing with let me think a bit. 1 over x square plus 2 plus let me think, 2 over x plus 1 equals to 0. How do you solve this equation? One way you could do it is to multiply by x squared throughout. Then you'll be left with 1 plus 2x plus x squared. Right? Okay, good. Then you can factorize, you get x plus 1 bracket square, then x equal -1 twice. Okay. Another way that you could have done this is to interpret this as, so let's say I change the question now to 1, okay. No, don't change the question. I can reinterpret as 1 over x bracket square plus 2 times 1 over x plus 1. Then I can let y equals to 1 over x. Does this look familiar to you? This kind of question?
Yes.
Sub y equal 1 over x. This is from Amax. Actually, no, Emax. This is from Emax. One of the difficult questions. Okay, then you get a quadratic in form. Then you can solve for y again. You get y plus 1 bracket square equals to 0. So y equals to -1. And then you get what? 1 over x. Remember, after you do a substitution, you cannot stop there. You have to sub back in with 1 over x. I was hoping that you remember this kind of question, so I can link it back to this idea of replacing the y back with expression in terms of x. So flip it around, you still get -1. Flip. But remember, you cannot stop here. After you do a substitution, you don't just solve for y. You must replace it back with the original expression in terms of x to solve for x. The question started with x, you must answer in terms of x. So yeah, that's why I have my step 4 over here. I added an extra step 4. Replace the u back with f of x. This one is quite obvious. Please remember that. Okay? Can. Eliminate x, eliminate dx, and then replace u back with f of x. If got definite integral, you have to change your x limits to u limits. Okay, go back to the example. Yeah, so this is your final answer already. That was one example for substitution. Then the rest will be your homework. Question 7, blah, 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 blah. And integration by parts. Okay, now I go through my final part E. Again, recap, we have 5 parts, A, B, C, D, E. Part A is standard functions, algebraic, exponential, trigonometric. Trigonometric got 3 parts, the basic, the squares, and then the product of trigo. 22 formulas in total. Some of them can be MF26, some cannot. Then part B, A, B, C, D, E, we're now in part B, integration of product and modulus. This is product, reverse chain rule. This is modulus. Sketch the y equal f of x, split the integral up at the pointy ends, or the points where they cut the x-axis. I haven't talked more about it. I need to talk more about this. Please remind me, I haven't finished talking about this. In the future, not today. Then part C is integration of fractions. So there's 2 steps. Step 1 is to check if the fraction is improper or not. Improper, you do long division, you get this quotient plus the remainder over dx. This guy, you have to deal with it. How do you deal with it? By using step 2, which is what I'm talking about here. Step 2 is LFP, ln formula partial fraction. Ln means you can use reverse chain rule, f prime x over f of x. You get ln of modulus f of x. Part of this trick that you need to know is the a times px plus q plus b trick, which I have already shown you in the example, right? Not here. Is it over here? Right? 4x plus 9 rewrite as 2 times of 2x plus 5 minus 1. So you can split up the integral. The first integral, factor 2 can take out. You're left with 2x plus 5 over x squared plus 5x minus 3. This guy is your f prime x over f of x. You can get your ln modulus denominator. Second integral, you just have to complete the square and solve it. Right? Must remember this trick. 4x plus 9 rewrite as, you start with f of x equal denominator, f prime x equals to something. Then after that, you rewrite it as the numerator, the original numerator equals to what you want as the f prime x on the numerator. You wish to have a f prime x on over here, but you times a and plus b. Solve for a, solve for b. Okay, moving on. That was step. That was the L. Now you got F and P. F and P. F tells you that if you follow these formats, you will have to use the standard formula. My standard trick is to make sure my a square is a 1. Notice also that these are all two terms only, quadratic and constant. So you're missing a linear term, you must complete the square. Okay, make sure you complete the square. Okay, actually over here also complete the square, sorry. Okay, so that you can get it into this format, these 4 formats. But for part 3 and part 4, what's so special about it? You have to satisfy these 2 rules. So what's my recommendation?
Use partial fractions.
Yeah, which leads me up to my next point, P for partial fraction. Then just split it out as partial fraction, then you can integrate term by term. Okay, that is step 2. That was part C. Okay, A, B, C, D, E, A, B, C, D, E. We have gone through A to C. Part D also talk about it already by substitution, step 1, step 2, step 3, and then of course step 4, replace the U back with f of x. This one I don't repeat. We just finished already. Then now finally, part E. Okay, part E. Okay, finally, last one. Part E is telling you to do integration by parts. It's derived from the, I call it IBP. It's derived from the product rule. Okay, the integration by parts follows the following formula. Integral of u dv by dx is equals to uv minus integral of v du by dx, where u and v are functions of, u is just short form for u of x, v is just function for v of x. Okay, it follows this formula. Now this formula is not, notice that I never put the lower upper limit. If you did, okay, I'll just put it in. So if it's x1 and x2 here, it will be draw a vertical line x1, x2. You know what this vertical line means, right?
No.
Okay, it just means that you have to sub in, you and v are general expressions in terms of x. You later then sub in the x2, sub in the x1, and then you minus.
Oh, okay.
Like for example, 2x plus 3, bracket, then draw a line, then x equals to 1, x equal to 2. It's really just short form for saying 2 times sub in the x with a 2 plus 3, minus away 2 times sub in the x with a 1 plus 3. Right? Okay, this is an example. I don't want an example over here. I'm going to throw it to the bottom. Examples are not very relevant here. You should know this at the back of your mind somewhere. Okay, then moving on to the theory. Moving on with the theory. So this is the formula, and then you also got lower limit x1 and x2. How do we derive this formula? It's really just product rule. Remember product rule is uv, you got differentiate, you become u prime v plus uv prime. Take one, differentiate the other, plus take the other, differentiate one. Then after that, you integrate throughout. I'm gonna be lazy and use just the integral and not put the dx. Integral and derivative will cancel each other off. You're left with a uv equals to integral u prime v plus integral uv prime. Now, if I just make this guy the subject, integral uv prime will be equal to what?
The u prime v.
Bring over, so it becomes a minus.
Oh, the uv minus u prime v.
Exactly.
Yeah.
Integral of u prime, yes. Which is exactly what we have here. But wow, this formula a bit complicated. I don't like. So I like to come up with a mnemonic for it. It's called the what's that? Kim's-D rule. Remember Kim's-D? K-I-S-D-I. There's a U here, there's a dv here. Here's how we do it. Let me draw some arrows. Keep. Wait, I should write down like this. K-I-M-S-D-I. Keep. Integrate. Minus. S for Taoge. Tau Ge, how to spell? Then D is derivative. Notice that this is a noun, not a verb. No, sorry. Yeah, wrong. Should be differentiate. This is a verb, not a noun. And then the other one is integral, not integrate. It's a noun. Because you just need to copy and paste. So K means you keep the U, okay? Keep the U. Then I, the next one will be, V is a I. Why do I say I? Because you're integrating the dV by dx to get a V. Then there is a minus, Kim. Kim is a minus M. Then S means the Tau Ge over here, the S. Right, the integral looks like a Tau Ge. Okay. Then the V, V is D. What is D? D is for differentiate. Why do I say differentiate? Oh, wait, sorry. Yeah, wrong already, my mnemonic. Can I just swap it around so it's easier for my DI? Okay. Yeah, so here the du by dx is D because it stands for differentiate the U. Then after that, the I over there represents the last letter I represents V, which is the integral of dV by dx. A nicer way to write it down would be like this. Integral of U dV by dx integral is equals to U V minus integral V du by dx. Notice, nothing. Maybe I should, okay, I'll keep it this way. Then here, differentiate. Solid line means you're actually doing work. You need to do something. Notice the U, copy and paste, nothing happened. Then after that, you differentiate. Then there's a pattern as well. This guy to this guy, what do you do? Integrate. Maybe just to make it look even nicer, I'll just use use a broken pen ink and I'll write down NOTHING. Oh, very difficult to read. Do you get what I'm saying?
Yes.
Yeah, you do nothing. Okay, just bring it down. Then here you integrate, you do something. Then over here, you do nothing. Okay, that's a pattern. Do nothing, do something, do something, do nothing. Minus integral. That's another pattern you can see. Honestly, some students find this quite confusing. So the best way is really just the table method. What is table method? Table method means you draw U, then you write down dV by dx here as a table like this. Then you fill in the blanks. Just copy and paste. Identify what's your U and what's your dV. Then after that, U transform into what? After U, what do you get?
The
What's a
dx.
Then you see U here. The partner of U is du by dx. So du by dx. Then you see dV by dx here. You see dV by dx here. Where else do you get the partner of dV by dx? What is the partner? Here. It's just V. So what you're really doing is over here you are differentiating. Over there you are, maybe I should be consistent. Red color for differentiate. This is differentiating. And over there is integrating. Okay. Then after that, you just need to slash horizontal. Your final answer will be UV, the diagonal, minus away integral of du times V. Du times V. Can see or not? UV minus integral duV. UV minus away integral of udV. Sorry, du times V. Okay. Leading diagonal minus horizontal, bottom. That's another pattern that most students use. So how do you, the most difficult part is figuring out what is your U and what is your V. This is the most challenging part. I'm just going to draw a huge question mark. Okay, how do you figure out what is U and dV? So that's when we come up with another mnemonic. Maybe I should write down on choosing u of x and dv by dx. This is a heuristic. Heuristic means it doesn't always work. Sometimes work only. It only sometimes works. Sometimes works. Most of the time. Most of the time. So you know the mnemonic? This one?
Yeah.
LIATE. What does it stand for? LIATE. I need to zoom in. Logarithmic. I'll just log. Inverse trigo. Algebra or algebraic expression. And this one is trigo. This one is exponential. Which one do you think is the easiest to integrate? Is it the top one or the bottom one?
The top one.
Huh? Integrate. Logarithm is easy to integrate. You want to try for me integral of ln of x? You tell me, is it 1 over x?
Oh, why differentiate?
Yes, only differentiation will give you 1 over x. Integration, much more difficult. Okay, not true. Integral of ln of x, you need to use integration by parts. You need to know the trick. 1 times ln of x dx. Same thing with, let's say, for example, sine inverse of x. You need to know it's 1 times sine inverse of x. Then from here, 1 is really just the algebra. Then sine inverse is like your inverse trigo. Over here, you should realize straight away. So I ask you again, logarithm versus exponential, the extreme ends, which one is easier to integrate?
The exponential.
Very good. So that's why I will write down an arrow over here. Ayo, my arrow. Like this, that says I. Then over there, it will say D. D for differentiate, I for integrate. So who's the fella that needs to be differentiated? Look at this table. Who is the fella that needs to be, we're trying to figure out what is U and what is dV. So who's the fella that needs to be differentiated? Is it U that's going to be differentiated? Or is it dV by dx that's going to be differentiated to get d2v by dx squared?
U.
Is correct, well done, yes. It is U that has to be differentiated into du by dx. So that's why for the choice of U, you would want to pick something that's closer to logarithms. And then you slowly work your way downwards, like a priority list. Okay, this is like the VVVIP if you want to select the U. So maybe instead of writing D, I'm just going to change this to U of x. Or maybe I'll use blue color. Okay?
Yeah.
Then at the bottom, this I here, it will be your dV by dx. So usually, this is just a mnemonic, it's a heuristic, it sometimes works, but usually it works. When you try to pick your U, right, you should pick somewhere closer to the logarithms. If you don't have logarithm, then you pick inverse trigo. Don't have inverse trigo, then you pick algebraic. Don't have algebraic, then you pick trigo. Don't have trigo, then you pick exponential. Then for dV by dx, you're gonna start with exponential because it's the easiest to integrate, right? Integrate exponential very easy, just copy paste. Then followed by trigo, then algebraic, then inverse, then logarithm. Logarithm should usually never be chosen because it's very difficult to integrate. Right? Sometimes it's also possible to have algebra and algebra as well. But that's a very special question, very rare. Okay, and you know what is log, inverse trigo, algebraic trigo, and exponential? I was assuming you know.
Yeah, no.
Huh?
Yeah,
wait, no, as in okay,
Yeah,
okay, can. All right, then let me just list down some examples first in case, just to be complete lah, huh? So logarithm, it will be something like ln of x. Inverse trigo will be something like sine inverse of x, cosine inverse of x, tangent inverse of x. Algebraic, some examples will be like 1. 1 itself is algebraic, okay? It's equal to x power 0. You don't write down x power 0, You don't write down x power 0, just write down 1 can already. Treat 1 as an algebraic. Then you got x squared. Sometimes you can have x plus 2 cube, also okay. Then trigo will be like sine x, will be cosine 2x. Go for linear one, power 1. Don't pick sine square, sine cube, very complicated. Then exponential, it will be e power x, e power negative 2x, also okay. Yeah, that's about it. All right.
Yeah.
Can yeah. All right, then that's all the formulas now. Let's just go through one example on integration by parts in the solution. Let's pick one. Okay, I'll just go through part A then. X times e to the power of 4x. Okay, I'll just scribble down somewhere over here. This is question 8a. Integral of x times e to the power of 4x dx. So remember remember the formula u dv. Integral of u dv is equal to uv minus v du. K I m, sorry, I'm using the simplified version, dv by dx. Sorry, I lazy. Okay, I don't be lazy. Write down the full thing. Minus, and s, and this one is, oops, I need to stop it around. This one is d, that's my I. Okay, I'm just gonna stop it around. So hold on a second. Then I can get my Kim's D. Okay. So remember LIATE, who should be, and then you maybe it's also easier if you just draw the table. Table method goes like this. Table method goes like this. Then you eventually need to get your du by dx equals, and then you need your va equals. So who's my u and who's my dv?
The du is e to the power.
Sorry, you mean dv? There's only u and dv.
Dv.
Okay. Dv is equal to what?
The e to the power of 4x.
Good choice. How about your u? Only one thing left.
Yeah, the x.
Exactly. Good choice. Why? Because now we can differentiate this easily. You get a 1. Then how about this one? Integrate, what do you get?
4e to the power of 4x.
Wrong. Integrate. Differentiate, you times integrate, you do the opposite. So it's divide by
4.
Exactly. Times e power 4x. Make sense?
Yeah.
You just check. Differentiate this, do you get back e power 4x?
Yes.
Yes, right? There's a 4x here, you must use chain rule, differentiate, you get a 4. 4 times 1/4, you get a 1. Okay, good. So what's the formula? U dv equals to, use the formula now? Or should I just go through?
Is x times 1/4 e to the power of 4x minus the integrate sign.
Okay.
And 1 times the 1/4 e to the power of 4x.
Very good. Don't forget to end off with a dx. Sorry, I should end off with a dx. Oops. All this are a bit extra. I don't want to distract you with all this. Your main focus should be identifying what's your u and dv. Then use the formula. Then I'm sure you know that you need to end off with dx. Right?
Yeah.
End off your dx. You know this, and must have an integral sign. Don't just blindly copy down the du and v. Forget the tauge. Okay. Kim's d. That's a s. S. Okay. Can. Then we carry on. This one simplify. You just get x e power 4x over 4 minus away. There's a 1/4. Okay, yeah, there's a 1/4, so I just take it out first. Then I now integrate e power 4x. How? Everything else in front keep the same, but how do you integrate this e power 4x? Deja vu. Looks very familiar. Integrate e power 4x. Did I do that before?
Yes. It's like there.
Yeah, so exactly the same, right? Good. So but you need an extra copy of the 1/4. Original 1/4 remains. Now you integrate e power 4x, you get 1/4 e power 4x. Again, there's a second copy of 1/4. So now you're done. That's it. Easy or not? Easy. Yes. Yes, easy. Sorry, no more dx. No more dx. Sorry, I made a mistake. Should be this guy, then plus c, then that's it. Okay?
Okay.
Then the rest will be your exercise. Let me see. Yeah, you go and work it out. Draw your table. I think table is the best way. Okay. Can I just try one last example with you? This is from I can just find the worksheet. One last example on integration by parts. So we got part A to part E. You're now a master of integration techniques. Later still got application. Where was it? Let me find the question. Sorry. It was a 2016 paper 2, I think. Hold on a second. Yeah, so now there's a common trend in the 2016 question. 2016 H2 math paper 2 question 2A part 1. So there's this common trend where they like to introduce an extra letter to you. I hope you can see my screen. It's okay, right? So in this question, they ask you to find this integral. Integral of the x squared times cosine of nx dx. They actually didn't put a bracket. You're supposed to know there's an invisible pair of brackets. And they tell you that where n is a positive integer. So 1, 2, 3, 4, 5, 6. Okay, you know how to integrate cosine x like this, right? 1x.
Yeah.
Sure, integration by parts. You see a product, right? Something times something, algebra and trigo. How about if I change to 2? Can you still integrate?
Can.
And how about if I change to 3? Change to
Okay,
4,
can.
5, 6? All can, right? So now if I generalize, the question is asking you, what if I change it to an n? A very curious person decided, hey, what if I just change it to a letter n so I can solve everything all at once? Does that work? Can. Just do it as per normal. Just treat it like a number. Treat it like a normal number. So let's see how we can do it. So remember, I write down again, u dv integrate equals to uv minus integral v du. Or rather, if you want, you can swap it around so you can follow the Kim's D. Then you need to draw a table. Okay, tell me what to draw in the table. Top left corner. U, correct. Top right corner.
dv dx.
By dx. Always dv by dx. Always have a dx at the bottom. So once you have u at the top, what's at the bottom?
du dx.
And the last one? Just v. Okay, good. So who do we pick first? What is our problem, the main problem? Is it the bottom 2 or the top 2? Who should we fill in first?
The top one.
The top 2, the top 2. So that's our main focus, the top 2. Who is u, who is dv? What rule do you need to use? L?
IATE.
X squared here is which one? L or I or A or T or E?
The algebraic.
Cosine? NX?
The trigo.
Okay, so who should be u, who should be dv? Remember dv by dx, you need to integrate. Choose wisely. Which one do you want to integrate? Closer to the right or closer to the left?
The algebraic one.
Why? Oh no, wrong.
Can integrate the cosine nx?
Yeah. If cosine 1x, can you integrate? If it's cosine 2x, can you integrate?
Oh, but it's
Cosine
not about
3x?
the same, no.
No, very far. Because if you choose this as your x square, then the other one is cosine nx. It's wrong. You eventually integrate, you get x cubed over 3, which means that eventually you're gonna multiply u by v, right? You're gonna take x cubed multiply by cosine nx. So you just make the problem more difficult, you know. Wait. Sorry. No. Let me think. Oh, sorry. No. Actually, it still might be possible. X cubed is multiplied. That's the answer. You're gonna integrate this pair, which would be if you differentiate cosine, you get sine with a negative and whatever. But yeah. Eventually, you're gonna integrate this pair, the product of v du or du times v, which is x cubed multiplied by a sine. So you just made the problem more difficult because you're gonna increase the power now to 3 and you change this to a sine. That doesn't help to simplify the question.
Oh. Okay.
Yeah.
So it's the cosine that is integrated.
Yes, correct. Okay, both are very ugly. Both are not very nice to integrate. But you must follow this rule, which says that those that are closer towards the right should be preferably integrated. So over here, you see you got A, you got T, you look at your LIAT. Right, I write it more separately. A is this fellow, T is that fellow. Who is closer to the right side? A or T?
The T.
T is closer to the right side. So that means you would usually want to integrate the T. It doesn't always work, but for this specific question, it does. Okay, so you pick T as the one that you want to integrate, which means that you have to pick it as the dv by dx, so you integrate it later. So that's what we're gonna pick. We're gonna pick, so can you tell me what's U? U is?
The x squared.
Okay, then how about the dv by dx?
The cosine nx.
Very good. Okay, now we try to do it step by step. So you go to du by dx, differentiate, what do you get?
2x
Cosine nx, integrate, what do you get? Think of n as just a number.
is 1 over n times sine nx.
How do you check if you integrate correctly? Word by word.
Differentiate.
Is it correct or not? Differentiate sine, you get cosine. Copy and paste the argument. Don't forget the 1 over n. I mean, 1 over n is from the b. But now we are trying to differentiate, right? So there's a nx. Differentiate, what do you need to do to your nx?
Multiply.
Multiply by the derivative of the inside function. So times n. What happens to your n? Cancel off. Then you're left with cosine nx. Let me show you a simpler example. Let's say it's a cosine of let's say 5x. You try to integrate this. What would it be? The answer is 1 over 5 of sine phi x. Why? Differentiate. Differentiate sine phi x on its own without the 1/5. You get cosine. Chain rule tells you have to times 5. So now if I differentiate 1 over 5 of sine phi x, isn't that just throwing the 5 over to the other side? Then you're just left with cosine 5x. Does that get back my original answer?
Yes.
Yes, okay, then it's correct. Now it works for the case where it's 5. You can try for all the other numbers. In general, it will work for any positive integer n. So n becomes 1 over n. Can you understand the pattern?
Okay.
Can Okay, I'm just going to get rid of this irrelevant information. So now we can answer the question. This integral is nothing but, use the formula. I zoom out.
X squared times 1 over n sine nx minus the integrate sign, then the 2x times 1 over n sine nx.
Well done. Good. Just put this here. Pick trigo as dv by dx to integrate, because t is closer to the right than a. Right, t is closer to the right compared to a, so you pick t as the guy to be integrated. Trigo. Later you integrate. Okay, yeah, so anyways, carry on. What's the advantage in doing that is that, let's simplify this, x squared times sine of nx all divided by n. What's so good about this? Minus integral of 2x times 1 over n sine x. You ignore all the constant coefficients, just factor it out. So it's minus 2 over n times x multiplied by sine of nx dx. What is so useful about this? It has reduced the power. We have reduced the power. That's the advantage. Can you see? By differentiating, we reduce the power. It makes the final integral easier. How do you integrate this? You need to do a second round of integration. Okay? Second round of integration. So draw the table again. Round two. This one, you see that there's another x multiplied by our trigo. Algebra times trigo. what do you need to do? Use what?
By parts.
Exactly. So let's just copy down everything first. Then later we fill in the blank square bracket. Okay, so what do you need to do? Draw table again. Fill in the blank top left corner. What is it?
The U,
Well, top right corner is
the DVD.
good.
Then
Fill in the rest.
U, DX, and V.
Which one do you focus on? Top or left? Top or bottom?
Top one.
Yep. Please don't go and copy paste the exact same thing. Pick a new U, pick a new DV. Here's your new integral of dx of this guy.
The U is X.
Good.
Then the
Then-
du is the sine and X.
Exactly. So let's do, so what is du by dx?
1.
What is v?
Is 1 over n negative cosine and
Yeah.
X.
I'll just put the negative over here. It's the same thing. Yeah, correct. Good. Differentiate cosine, you get negative sign. Negative will cancel off. You're back to a positive sign. But because there's an nx, chain rule tells you need to multiply by n. N times 1 over n cancel off. You're left with sine nx. Okay, good. So your answer is what's inside the square bracket?
Oh, the X times negative 1 over n cosine nx minus the integral sign, then 1 times the negative 1 n cosine nx.
Very good. Yeah. Plus c can put later. Plus c can put later. Okay, almost there. So second round of integration. Then let's clean up. So everything else at the front stays the same, but then now you got negative 2 over n multiplied in. Negative 2 over n times this guy, negative 1 over n, you get positive 1 over n square, right?
Yeah.
Are you clear on how I got n square?
Yes.
N square. Are you clear on how I got a positive here?
Mm.
Right, minus times minus gives you plus. N times n gives you n square. Okay, then 2 times 1 is 2. That's obvious. Then x, don't forget the x cosine nx. Then here you got minus 2 over n times minus. What do you get? Oh, actually do it a bit faster. Minus times minus times minus. What do you get?
Is minus.
Correct. Yes. So minus what?
Minus the 2 over n square.
Good.
Cosine nx.
Cosine nx. What's missing?
The plus c.
Nope. Oh, I'm sorry. I made a mistake. I didn't put in the dx here. Sorry, my mistake. What's missing? You times the constants. That's fine. But have you integrated the cosine nx? Have you
No.
integrated the cosine nx? Maybe I
No.
shouldn't use like let me just change the color. I don't like this color. Let me change it to, I don't know, this. Haven't. So that means you still need the integral. So you need to go a third round of integration. Third round, do you need to use, but this case, look at this one. Cosine nx, do you need to use integration by parts?
No need.
Don't need already. So everything just copy and paste. Can you integrate for me, please? What is the answer?
The 1 over n sine nx.
Yes, correct. So this one will just be 1 over n times sine nx. Exactly. Differentiate sine, you get cosine. Chain rule, differentiate nx, you get 1 over you get a differentiate nx, you get a n times 1 over n, cancel off, become 1. Okay, then you plus c. Done. Okay, you can clean up a little bit more. Here will be n cube. So you'll end up with 2 times 1 is 2, n squared times n is n cubed. Okay, can? Yeah, that's how you do it. This is expected in A levels. You have a n here. All right, that's all. And then the rest, let me see. Can you do everything else already? I think you can. This one, integration, can already. You can do all the questions. Just take note that sometimes you have this unknown p. You must integrate it in terms of p. Then eventually, I do integrate separately, get two equations. Then you equate them. It will be an expression in terms of p. Then solve for p.
Oh, okay.
Yes. Upper limit sometimes got a square as well. Need to use integration. You may also need to use your GC to calculate some integrals if it's a definite integral. Let's see. Anything else special that I need to take note of to remind you? Honestly, that's all there is to integration techniques. The rest is all practice.
Okay.
Yeah. Okay. And sometimes got some special questions. Go think about it. Okay, then that will be all for today. Finish up the rest of the questions. That's your homework.
Okay.
And that's all.
Okay. Thank
And
you.
thank you.
Okay.
Bye-bye.
Bye.